So, good evening, engineers. Good evening to everyone here in this room, and good evening to everyone online. So, this is Nziza Global again. We are back to our second day for MEP Design Expert Seminar about MEP design for hospitals projects. So, it's time for training. We have been waiting for our colleagues for a long time, as we are now 3:15 minutes about, and we have been supposed to start with our training at 3 p.m. Now we have 13 minutes added to that time. So let's start, and others will continue with us where will it be after when they join us. So I would like to call Mr. Engineer Rajesh to take the floor and continue with the second session of today. Mr. Engineer Rajesh, the floor is yours.
I'll unmute and I will increase my mic now, all right?
Yes.
Okay. All right. Welcome to everyone. A very good afternoon. I hope you guys are well rested from yesterday's dose for HE. We still have a few slides to go. It's not all of the slides that we need to cover. But today, my plan is to have as much on-hand experience for all of you. There is an echo. Maybe you should unmute or something. Good afternoon. All right. Okay. Yeah, as I was mentioning, today we do have some part of the theory that we'll be considering. Excuse me. But apart from that, we will also be looking on hands-on training, be it for the heat load calculations, be it for the duct sizing, be it in Revit, for linking the model, drawing ducts, drawing pipes, selecting equipment, so on and so forth. Again, there is a lot to cover today as well. We'll try to push as best as possible to get as much covered as possible today. And then, as I mentioned yesterday as well, let's make this session an interactive session. If you have any questions, please feel free to interrupt me. I will try to address that question as best as I can. That also applies to the team that is online. Please do type out your questions in the chat box and we will try to address it as soon as possible. I have with me Emmanuel letting me know that there might be a question online. So we are monitoring that as well. So, all right, without further ado, I will start presenting my work. Share the screen. Yes. So I will share my screen as well. Thank you, Emmanuel, for letting me know that. All right. So I'm sharing my screen and I will present my screen. Oops. Just a moment. Okay. All right. Is it visible now? Online? Yes. Okay, perfect. Just a recap at the same point that we left off yesterday. We had a discussion regarding the dual duct schematic used in the central HVAC systems in hospital, right? So I'm not going to go deep into it right now because yesterday we did have a lot of brainstorming regarding different aspects of the dual duct system, how they work, where they are used, and how it can be used with the advantages and disadvantages that we can explain it to our clients, right? So this basically was the transition into the variable air volume systems. Okay. So the variable air volume systems, as I mentioned yesterday, they act very similar to constant air volume with the exceptions of the variable frequency drive if the motor is an AC motor, or variable speed drive is if the motor for the fan is DC motor, right? So similar to the constant air volume, the variable air volume will also have two types. You will have the single duct with terminal reheat. The advantages will be the similar one. Over here, the biggest advantage on top of the constant air volume that we get is we get to ramp up and ramp down the air volume as required. So let's say only as yesterday's example, we only have 3 out of the 10 operating theaters in operation. You can just ramp down to the CFM, to the air volume that is required, to the volumetric flow rate that is required for those 3 operating theaters. You don't need to run the entire system at 100% capacity, right? So again, as I said, both of these constant air volume as well as the dual variable air volume have the same distinction between the type of the application that we will have: the single duct with terminal reheat and the dual duct. All right. Again, I'm showing you the exact same schematic over here, where we have the return air fan, we have the relief air, we have the outdoor air, we have the pre-filters, heating coils, the steam nozzles to introduce any relative humidity into the air, the supply air, freeze strat if your project is located in an area which is prone to go sub-zero temperatures. After that, we have another introduction of steam nozzles if required to meet the condition before it goes into the 2 ducts, for making sure that the air is then circulated to the typical areas that we are looking over here. All right. So again, I'm not going to invest too much time because we had a detailed discussion on the on the constant air volumes. The biggest difference between the constant air volume and the variable air volume would be the VFDs that we will have to ramp up and ramp down the given CFM required for a given room. All right, so till now, what we are looking at was the all air-based system, right? We were dealing with all the air-based system. Now the other system that is classified by ASHRAE is the air and water system. All right. So air and water system, we have generally categorized into two areas, 2 types of equipment. One is the air and water induction units. Dear friends, please note over here, these are units that were very popular specifically in the US during the 70s and 80s. So this is kind of a technology of a bygone era. You will hardly come across something like this that is being specified on newer projects. On newer projects, the constant air volume, variable air volume, there is another system that we will talk about in some time. Those will be used. But just to make sure that you understand, because this is something that you will find on the existing sites if you are doing some site visits. All right. On those existing sites, you might encounter the air and water induction units. Right. So again, this is just for the information for you guys to understand that there might be these systems that you might come across on the field. There might be the request from the facilities manager to reuse those equipment. All right. So basically what happens is the induction system will get the air supply, right, from a central air handler, and then it will be transitioned into a high pressure or low pressure terminal unit. All right. High pressure is when you have high pressure coming into the unit, into the terminal unit, and low pressure when you have the low pressure coming into the air low pressure coming into the terminal unit. We have spoken about positive and negative pressure yesterday. So this is on the basis of that. And then the supply air that you have supplied to the terminal unit is then introduced into the nozzles, all right, that supply the air into the given space. All right. Again, the reason why there is this name of induction units over here, the reason why we call it the induction units, because the change of pressure is induced in some of the room air to flow through the unit. Right? That is the reason why you will find this particular name attached with this given unit. Again, space temperature is maintained by the coils that are mounted in the unit itself, and that it controls, the controls are basically on the motorized valve that will be modulating to allow certain quantity, certain volume of water to pass through the coil, right? So along with this, let's move ahead with the next one, which is kind of popular. I wouldn't say it is very popular, but in developing nations, you will find this technology every now and then, called the fan coil units. Okay. I would personally recommend you to use this as a last priority. We'll take a look at why that is the case. So fan coil unit is basically a smaller air handler, just supposed to serve one zone. The central air handler was a bigger air handler that was supposed to serve multiple zones. All right. In this case, we are just talking about one small air handling unit serving just one zone. All right. What happens is the water from, let's say, chilled water or heating hot water comes from the central chiller plant or central heating plant, and then that is supplied to the coils of the fan coil unit. Right. Along with the coils, you will also have the fan in the fan coil unit, pushing the air and then recirculating the air in the same room, right? So as I said, the fan continuously runs to recirculate the same air in the room. You might need another source of outside air to serve the purpose of the outside air, the minimum outdoor air changes per hour that we were looking at, right? If required, there might also be heating sources. As I mentioned, heating water coil is also introduced in the fan coil units in case heating is required to the air. But along with that, depending on the type of geography that you are on, right? Like in some geographies in the world, the natural gas might be much cheaper as compared to electricity. And if the government allows it, they are fine with using it, right? Again, since the unit is smaller, we will have multiple units for different locations. There will be a lot of units. So there will be a lot of maintenance at different locations that might need to be taken. All right. In that case, the filters that we are using in the fan coil units might not be of that high efficiency that we are trying to meet over here with the HEPA filter or the MEP 16 filter, so on and so forth. Talking about the advantages of fan coil units, it can be economical for providing multiple air temperature ranges to meet the loads of the given space, heat loads of the given space. In addition to that, since the unit is smaller, it will fit in the ceiling space as well. So it will make the space look pretty because the unit will not be directly visible to the occupants of the room, right? Again, it is very suitable for low temperature heating as well as for heat recovery as well, because not the entire quantity of water will be exactly used for serving the loads, the heat loads in that given area. Talking about the disadvantages, some of the fans and motors tend to be very inefficient to work with. And that is why your overall, when you add up the power usage by all of the fan coil units that you're using throughout the campus, you might be taking an energy hit as compared to having one central air handling unit. So the next one, I'm just continuing from the last slide because the disadvantages were not fully handled on that slide. So continuing on with the disadvantages, dehumidification, right? If your air is too humid, it has too much moisture in it, the dehumidification that needs to be done to maintain the relative humidity that we checked in the table yesterday, it might be very hard. Why it is hard? Because it just has a small coil as compared to a big coil in a central air handler, right? So that is the reason why the high latent load, if you have, it will be a bit difficult to maintain those latent loads with these fan coil units. As I mentioned, there are multiple fan coil units in a building, in a hospital, leading to more time for maintenance that is required, and hence it will take more man hours, leading to more intensive efforts on the maintenance side. This is another thing that I mentioned, that try to use this option as the last scenario. The reason being the condensate drain pan, right? When we have the air that is being brought down in moisture, relative humidity, it will have moisture taken out of the airstream. Okay, it is something similar to if you have a bottle of water that you take out from the refrigerator and then you put it on your outside desk somewhere, you will start seeing water droplets on the bottle, right? So that is exactly what condensation is, right? In this case, if you have the bottle of water that is so cold and it is brought outside the refrigerator, that condensate will be dropping off on your table, right? So something similar is happening. Consider this as the coil. You have chilled water going on from in one end and chilled water coming out from one end. So when the air is passed through the coils, the condensate will start accumulating on the coils. The condensate has to drop somewhere. So in this case, if you have a fan coil unit, it will be dropping in the condensate pan. There will be a pan down over here. The condensate will drop in the pan itself. If that is happening, the condensate, if that is not pumped or plumbed somewhere properly, it will start accumulating over there, and that will be a reason for problems like Legionella or bacteria to start cultivating in that condensate pan. Now, since our fan coil unit is so close to the patient, right? If that fan coil unit is serving a patient room and our supply air stream from that fan coil unit picks up that Legionella, that is bound to make the patient even more sick. That is one of the major reasons I mentioned that keep this as a worst case scenario option if you don't have it. All right. And apart from that, of course, if you have a fan running, not something similar to what we have in these DX split units, it's a bigger fan as compared to this one. So it makes more noise. And since the units are closer to the occupants in the room, it will make more noise and make them irritated again, right? And again, as I mentioned, you can either heat the air or cool the air before it goes into the patient area, so on and so forth. But that is basically leading to energy losses, because if you have a different season going on, if you have a winter season going on, and if you're trying to cool that air, tends to become energy hit on your energy bill, right? And again, the fan coils have a higher first cost because they have improved controls, because they are handling a very small area for controlling the situation. So that is why the fan coil units seem to be for first cost, upfront cost. The capex will be much higher as compared to the entire system for the central air handling unit if you compare it for the entire project. All right. So now that we have looked at all water, we have looked at water and all air. We have looked at all air yesterday and some part of today. In the previous slide, we spoke about the water and air system. Now we will talk a bit about the all water-based system. Okay. As you see, friends, in the previous one, we were looking at just water, right? Over here in the fan coil units and the induction units, we had introduced water in conjunction with the air. That is why it was air and water system. Now what we are talking about is all water-based system. Okay. This one is the first type is the perimeter radiation. So there are three types of heat transfer modes, right? Conduction, convection, and radiation, right? This perimeter radiation will take care of that, will take advantage of that radiation heat mode of it, right? You're not talking about conduction in this case or convection in this case, it is the radiation. How it will take care of it? We will have baseboard heaters, baseboard radiation panels to take care of the building loads. What are baseboards? You might see something over here, right? The small chunk of tile that you have in the lower bottom where the floor meets the wall, right? Something similar, that is also called as a baseboard, but that is a baseboard just for the wall purposes. This baseboard that we are talking about will have basically a coil with fins on it, and you will have heating hot water going through the coils. All right. Cooler air, again, the cold air by its nature is heavy. So it tries to settle in the bottom of the room. Even in, like, let's say the valleys that you have in Kigali, in the evening, since it gets colder, the cold air basically settles in those valleys. In the room, the same phenomena happens. The cold air tries to settle in the bottom, and to make sure that the temperature pattern throughout the room is properly adjusted, you have baseboard heaters taking care of any outdoor conditions that might need it, right? Again, air moves towards the wall, sensing the high pressure of the heat over there, and it properly takes care of the facade loads in this case. The advantages of a perimeter radiation, again, perimeter radiation element is only applicable if you have the exterior wall, exterior window. At that cases, you cannot have it on an interior wall. You need to have it on the perimeter of the building, on the exterior wall, right? Again, it is very flexible because you don't have any fan in it. You just have a fin element. In that, you will have the coils that will be circulating the water. Along with that, the water transport is more as compared to what you would have in a typical air system, all air system or water and air system. Piping, if you have any renovations happening in the hospital, you can modify the sizes of the baseboards by modifying the piping as well. Again, you can use multiple sources of heating. You can use steam heating, you can use hot water heating. In case you have option of burning any fossil fuels, you can do that as well. So the advantages are repeated on the next slide as well. The disadvantages are there on the next slide, but let's take a look at the next type of all water-based system, that is the radiant panel system. All right. Till now, what we were talking about was baseboard heater that are mounted low on the wall in height. The radiant panel, on the other hand, are mounted on the ceiling. All right. So the radiant energy that transfers in the perimeter radiation is from the bottom up. Over here, we are trying to push from the top down. As I said, during heating, the thermal energy is emitted by a panel. So that panel is something similar to, you can say, acoustical ceiling tile. Okay. Again, you will have a coil of hot water or copper tube going through the panel, and that will emit heat, so that heat is transferred to the area below. Next, talking about the advantages on this one. If you try to have something different as compared to what the architect is asking, usually they will come across this aesthetic problem. It doesn't look good in a building. It stands out in the room. So aesthetics might be an issue. It is only applicable when we are talking about in the ceiling types. It again minimizes any sensation of drop, since the heat that is transferred is in a linear gradient type. So it won't be hot in one end and cold in other end. It will be gradually dropping down in temperature till you come to the floor level. Next, talking about you don't need to utilize any floor area because it is in the ceiling. So that gives you space on the floor. That gives the architect space on the floor to use the floor area as much as needed. Virtually, it is silenced because you cannot directly identify it. Individual zone control, you can have just one radiant panel to one patient care area and call it a day. Again, since the system is fully jam-packed, it's not open to any other elements of the room. So that is why there is the infection probability is much less in this case. All right, talking about the perimeter radiation, again, this is an advantage rather than a disadvantage, that the transfer of contaminants from one room to other room is limited because you don't have the air from one room going to the other room. It's just that same air that will be in the given room. Does not transfer noise from one room to other room. Can be decorated if you want to get it painted. If you want to get it camouflaged with the wall color, you can do that as well. Talking about disadvantages, it can be used in heating only mode. We cannot do a cooling because the concept of radiation with respect to the room only comes into picture when we are talking about heating. Of course, when you have the baseboard heaters which are pretty low, it leads to dust getting accumulated. So cleaning them regularly becomes a problem. It can present with infection because, of course, if you have dust and dirt that will be captured in those fins, that will create infection problems. Of course, may require enclosure because it is very prone that it might get sabotaged or vandalized because you're hitting into the baseboards. Next, talking about the radiant panel. Again, the output out of the low radiant panels is pretty low because, again, we are trying to heat from top bottom. Requires a separate ventilation system. This, as I mentioned, this is not an air-based system. So you'll require a different ventilation system to take care of the outdoor air, minimum outdoor ACH that we mentioned yesterday. Next, the first costs are usually higher as compared to what we have in other systems. Next, now this were the three types. If you remember what I mentioned yesterday, just a minute, I will open the slide that we mentioned yesterday. So this is a slide from yesterday where we had spoken about the primary three of the central HVAC system. We went through the all air systems, we went through the air and water systems, and we went through the all water systems right now, right? And for this, I had given you a word of caution. The reason being this particular chart on the flammability and toxicity. Now we'll come back to the system that I'm going to talk right now, which is exactly that same system. Again, you will find these systems. I'm not going to say that these systems are not used in the hospitals. These are also used in the hospitals. But if given a chance, you have to design the hospital, I would recommend keeping this as the very last option rather than the very easy option to approach. Okay, so that is the unitary refrigerant based system for air conditioning. All right. So now we are talking something about the PTAC units, packaged terminal air conditioning unit. All right. So what is a packaged terminal air conditioning unit? You might have seen the window ACs, right? In the 90s, window ACs were very common. What that was, like the compressor, the evaporator coil, the condenser coil, the expansion wall was just in one unit. Compressor and condenser were outside, evaporator and expansion wall was facing the indoors, right? And that was what was being used for a long time back. So this is similar to that. You have everything packaged into one unit. All right. Again, when you are talking about packaged air terminal unit, we can use it in heating or cooling mode. Again, it is a self-contained unit. I said it's just one unit. You can plug and play in one location. Advantages, of course, it's much cheaper as compared to the other systems. It's very good if you want to do a tenant sub-metering, right? In hospitals, you don't usually come across tenant sub-metering because the entire hospital is usually owned by one group or one owner. When you come to something like office spaces, that you have a core and shell and you are subleasing different parts of the core and shell, then in that case you can go ahead and have a separate sub-meter for the energy consumed by one of the given occupant, right? Again, since it is much smaller, it requires smaller space for installation. And then again, it will require the space at the perimeter of the building we are talking about. As I said, it's like a window AC that we are talking. Disadvantage, again, humidification control, not really a thing that you can do properly with PTAC units. Economizer mode, we have spoken about economizers yesterday when we were talking about the central air handlers. This cannot have the option of economizer because the manufacturers don't manufacture it that way. Next is the increased maintenance. Just like the fan coil units, you will have so many PTAC units throughout the campus. Going to serve and maintain each and every one is a tedious task. And then again, regarding the condensate, I have noted condensate again and again over here because that ends up being a big source of contaminants, making the patients more sick rather than getting them to be healthy and fine. And then again, since it is not meant for handling the ventilation load, the outside air load, we cannot rely on it for doing the ventilation. And since it is so close to the occupant, it tends to be very noisy as well. This is something similar to what we have over here, the package, the split unit, that you will have one indoor unit and then you'll have an outdoor unit. What you'll have in the indoor unit, you'll have like the evaporator coil, the expansion valve, and then outside you'll have the condenser, you'll have the compressor, so on and so forth. So again, similar to the packaged terminal unit, this unit will also be a packaged unitary unit that is given by the manufacturer. Again, the advantages are it is very low cost as compared to what you will find on the central air conditioning unit. This can be used when we have limited space outside or on the rooftop as well. Disadvantage, again, requires space inside the building like this to mount it. Requires separate relief when economizers are used. There are options of using economizer modes as well. Distance between the indoor unit and the outdoor unit has a limit because you cannot run the refrigerant piping so long. It will be limited to a length that is given by the manufacturer. Zoning capacity, if you have it for one zone, you cannot use it for another zone usually. Again, for dehumidification, for condensation, it is very, very low possibility of dehumidification. And as compared to the grand picture in regards to the central air handler, this will use a lot of energy as compared to that central air handling unit. And again, the capacity for ventilation air, outdoor air will be limited on this one. Okay, this one is a bit unique. This is something similar to a packaged rooftop unit when you'll have a unit serving just one zone. It is again a contained unit, like a PTAC unit, but rated for outdoors. You can have ducts coming out of it and serving the areas. But the thing is, the cooling, heating will be done by the coils that contain the refrigerant. All right. Again, it is a self-contained unit. It will have a fan in it. It will have a filter bank in it. It will have cooling coils, heating coils, the compressor, condenser, all of it will be contained in the same one. Now the advantage is it is low on the initial cost, and it will be very useful if you have very compact arrangements that you're trying to do. Dehumidification can be better over here because you're trying to keep that unit somewhere outside and not in the room itself. Energy efficiency available through variable air volumes, variable speeds. Even this can come with, let's say, variable frequency drive or variable speed drive. By the way, there is one other technology in the market called as EC motor, electrocommutator motor. Okay, that up to 5 horsepower motor, you will be able to use it properly. But when it goes above 5 horsepower, the motor goes above 5 horsepower, it is generally recommended that we have a dedicated variable frequency drive or variable speed drive as needed. Again, if you have a packaged rooftop unit, if it is visible from the outside, it gives not a very aesthetically appealing look to the building. Higher maintenance since you have many more moving parts at the same location as compared to the chilled water system. And the capacity to have the ventilation air properly conditioned is limited in this case. Along with that, filtration also tends to be a problem because the manufacturer might not manufacture that unit for a HEPA filter accommodation. And along with this, I would like to have a word of caution over here. Before using any of these systems, make sure you have referred to ASHRAE 15 guidelines. Yesterday, what we had seen was ASHRAE 170 guideline. This is ASHRAE 15 guidelines. Okay. What ASHRAE 15 guidelines will tell us about is making sure that we do not exceed the amount of charge that will be used in the system for different areas. Okay. We don't want that refrigerant to leak into the air stream, coming back to the occupied area and harming the occupants. Okay. And another point over here, this is a joint collaboration between us, the consulting engineers, as well as the vendors or the OEM channel partners. Every given refrigerant, as we saw yesterday, 410A will have different types of toxicity. R32 will have different types of toxicity and flammability. They will be limited to the amount of charge, amount of refrigerant that is used in a given system. All right. So it is different for different refrigerants. So it is our collaborative effort with the vendor and manufacturer to make sure we do not exceed that limit. All right. I will just run through the concept over here for the ASHRAE 15 guidelines. So just like yesterday, we will go to read only, and then on read only. If you guys want to, you can go, or else I'll just show you, because this is something that is usually worked out with the vendor, with the manufacturer's vendor. So you have ASHRAE 15/2024. Safety standard for refrigeration systems. This is the latest one. Some of the building codes have adopted to the latest one. Some have still not adopted to it. So whoever one is applicable, you can use that. So the interface between all of the standards and guidelines will be similar. So where you'll have on the left-hand side, you'll have the bookmarks, the page views, so on and so forth. I'm online, right? Emmanuel, I'm online, right? Yes. Okay. So over here, we will see the restrictions of refrigerant use, and there will be a graph associated with it, which will give limitations for the refrigerants. Okay, over here. We'll have a table associated with it. So this table will give us the maximum allowed refrigerant chart that we will have as per the area. Okay, if we have a room that is 200 square foot with a ceiling height of, let's say, 8 foot, the maximum refrigerant that is allowed will be 13.2 pounds in this case. Right? So again, this depends on refrigerant to refrigerant. So in case if you have a different refrigerant, I think so this is for 410A, but if you have a different refrigerant, please work with your vendor, because they would be the one who would be putting that table together, and there will be a graph as well. So maximum allowed refrigerant, if you are using one of these systems on your projects, make sure that you have it properly taken care of. Okay, again, a word of caution, it becomes life-threatening, it becomes fatal if we have not taken this into consideration. And again, as a rule of thumb, I would recommend that you would use these systems only and only possible if you have no other option among the given so many options that we have discussed. All right. Any question on this one? Yes.
Just want to know how you touch that the kitchen of someone within section and why
So if I understand your question, how do you calculate the refrigerant count for a given system? Right? I got it. Now, so let me go over there, repeat it again. Okay, so there was a question in the audience in-house for the folks that are online. How do we calculate the charge that is required in the system and then come to the conclusion, is this okay or not? Okay, so basically in a refrigeration system, let me check if I can have the whiteboard over here. Do you know how to have a whiteboard, Emmanuel? Do you know how to have a whiteboard? Whiteboard? Whiteboard for writing on this thing. Just a minute. Yeah, I got it. No, got it. It's. Okay. Yeah. Okay, and you can see my whiteboard, right? Yes. I'm moving my screen.
Yeah, you are moving.
Okay, all. Okay, so let's draw it out. Oops, no, but it's not visible over here. Okay, so in a given system, we will talk about a refrigerant, variable refrigerant flow system. Okay, so because that system inherently will have a lot of refrigerant associated with it. In a refrigeration, in a VRF system, let's say this is our condensing unit that is on the outside. Okay, what happens is we have multiple indoor units, right? So you'll have an indoor unit here, indoor unit here, indoor unit here, and they will be serving some other areas. Not necessary that they are serving the same area. There's let's say over here it's area 1. This is area 1, this is area 2, this is area 3, this is area 4. Now what ends up happening is you will have the two lines, suction and liquid line, right? Suction and liquid line coming to these units, right? There might be Y connections that you might have, or there might be also something called as a changeover box. Okay, what that does is it brings in just two of the okay, let's ignore this line for now. What changeover box will do is it will bring the suction and liquid line, and then it will have multiple lines that will be going to each of the fan coil unit or evaporator unit, whatever you call it. Indoor unit also it is called. All right. So now if you see this particular diagram, you will have a compressor in this particular condensing unit that sits on the exterior, right? And then you have all of this will be in the interior of the building, right? So now you'll start checking how much charge is required first of all for my compressor to run proper, right? Then the charge will need to be available in these given pipes so that if required, this unit can be run, or this unit can be run, or this unit can be run, or this unit can be run, right? So basically we are trying to see what is the linear length of each pipe. All right. And that is also where I was talking about the limitations on the length between the indoor unit and outdoor unit come into picture. It might be 250 feet, 300 feet, whatever the manufacturer is specifying, because after that there will be derating in the capacities of the cooling of these evaporator units. All right. So once we have them all by length, then we will have the amount of refrigerant charge that will be required in those pipes. One pipe will be smaller as compared to the other pipe, right? After condensation, it will be liquid after going through the evaporator. So the liquid will be in a different pipe, and the suction will be in a different pipe. The gas will be in a different pipe, and all of that will be required in a given system. All right. So this is basically the simplified version of what the manufacturer's rep will do. What you need to do is first of all put it on your floor plan, show the location where you require your condensing unit, your fan coil unit. So this is your condensing unit, and these are your fan coil units or evaporator units, whatever you call it, right? So give them the location, ask them that I want these piping to be routed. Based on that, give me the amount of charge that is required. Based on that, check which is the smallest room that is being served with these particular fan coil units, right? So that will be your worst case scenario. That will be your critical room. If let's say room number 3 is your critical room and there is a leakage in the gas over here and it comes into this particular room, and the room is not big enough, the volume of the room is not big enough to handle all of that charge, the person who is in that room is at the risk of something fatal of a nature. Does that make sense?
So this ASHRAE 15 comes once there is a leakage.
Well, ASHRAE 15 will, yes, the end goal is that if there is a leakage in a refrigeration system, that needs to be properly addressed. Okay. Now, since all of us are professionals over here who have worked in the industry for more than 3 years, you might have heard about machine rooms, right? Chiller rooms, machine rooms, that's what they are called. As compared to the VRF, the chiller might have a lot of more quantity of refrigerant. Okay. But the chiller is sitting in the machine room or chiller room. All right. But even that room will have occupancy at some point, right? Many a times what ends up happening is the facilities manager's office, facilities team office is in that machine room itself. In case there is a leak in that chiller, that refrigerant is going to flow in that room itself. In that case, there is something different called as a refrigerant evacuation system, that there will be sensors all throughout the room to identify if there is a refrigerant leak. If they identify a refrigerant leak, there will be an opening and then there will be an exhaust fan pushing all the air from the machine room outside so that proper levels of breathable air can be maintained in that room. All right. But this is a big setup that comes into picture when you have a machine room. When we are talking about patient rooms are hardly, let's say, 15 foot by 15 foot. Machine rooms might be 50 feet by 50 feet. It's a big room, big tall ceiling spaces, so on and so forth. But in that small space, if you're trying to consider dumping so much or leaking so much refrigerant will take care of it, it won't. That is the reason why I always make sure that we do not push for these systems as the first option. All right. Does that answer your question? All right. Perfect. Any other questions before I move forward? Anything online? All right. Okay. So, okay. So I'll go ahead and share my screen again. Okay, all right. So with that conversation out of the picture, again, try to use this as a, oops. Just a minute, I forgot to share. All right. So with that point out of the question, now you might say, okay, Tejesh, this is fine and good. From yesterday, you have been jammering about so many systems. But what do you recommend? Which system to use in which area, right? So for that, again, this is something that ASHRAE also specifies, like what type of systems is suitable for what type of areas. Okay. So let's say you have a critical care area, like let's say an ICU, CCU. You might want to stick with the constant volume, single duct terminal reheat. In case if it is a clinic, you might go anyway, constant, variable, radiant, whatever suits you best for that particular application and what you have option over there. Administrative and general support, if you have like a seating area, a waiting area, any record keeping area, you can simply go ahead with so many options that we have already. Over here, as I did mention regarding fan call units, these can be used, but in non-clinical spaces that we can use it. And again, these are recommendations, nothing hard and fast, but it would be better if we go with this area. And if you have support areas for clinical spaces, then you have some other options that you can take care of. On top of that, we will have the patient care units or patient care areas where you have multiple options. And if you have a laboratory, again, you have multiple options to choose from. So this is where most of the theory is concluding. We will get into the next thing is heat load calculations based on the Revit models that we will be setting up. Any questions till now before we jump into the Revit hands-on Revit work, hands-on calculations work? Okay. Anything from the folks online? Any questions? All right. No questions. Please.
You were saying that the refrigerant-based type of HVAC that you are for the like the last option.
Yeah.
But the reality of it's all we have.
Yes. I do understand that. As I said, I know that these are used very often in especially our countries, the developing nations that we have, and it ends up being on the cost as well. Okay. So yes, if required, you can do this is something of an advanced concept, you can do an energy modeling analysis that will predict the energy usage between these refrigerant systems and the chiller systems, or all air systems we are talking about. Okay, in the longer run, because if you are looking at building a building, specifically building a hospital, you're looking at it for a longer term. All right, it's not just like 5 years, 6 years, maybe like 25 years, 30 years, 40 years sometimes. So over the age of that building, if you try to compare a unitary refrigerant system as compared to the central air handling system, the central air handling system, from my experience, ends up being a lot cheaper as compared to the unitary, given the amount of energy they will be consuming, given the amount of maintenance that they will go through, given the amount of changes that they will go through, given the amount of man hours that will be. So that is again a different topic. Yes, I do understand the reality, and my task is to give you the best possible option out there. And as in general, as well as consulting engineers, we are basically the owners and try to make sure you have the proper calculations done for refrigerant flow, so that worst case scenario, if the refrigerant was to leak and it was to go into a room, there will not be any adverse effect, any fatal effects due to that leakage. All right, does that answer your question? I know it's not a very good question answer. Okay. There's something I saw on the chat. You must have done the file manual today for the Revit work as well as the heat load calculation work. Has everyone received it?
The link is not.
The link is not working. Link is not working.
The one that you shared.
I shared two different links, so we must use the second one.
So yeah, please download all of the Okay, I think so. I got dropped off. So for the folks online, what I was talking to the team that is in-house, you must have gotten a link from Emmanuel to download certain set of files. There are total 5 files and folders, a combination of files and folders. What we require right now is the hospital zip folder. If you can please save it on your local drive. That would be great. Please don't save it on your cloud drive if you have it. Don't save it on your OneDrive, Google Drive, Dropbox. Usually the Autodesk products, specifically Revit, will not work efficiently if you have them saved and operated from a cloud drive, except for Autodesk Construction Cloud, which is a different software altogether. So if you can please save it maybe on your desktop, in your My Documents, so on and so forth, that would be great. And in addition to that, please make sure you start saving these files as well. The duct sizer, the sizer tool over here, and the HVAC load calculation E20 spreadsheet. you are facing any questions, any problems, please feel free to raise your hand or just call me at your desk. Even online, if you have any questions, please feel free to drop your queries in the chat box. So, okay, there is a question online. Well, a comment online by Lawrence. Yeah, the mention is, as all water-based systems is not common, any reference project building having this option would be appreciated. Pictures of the systems at work or their components would be more informative. So let me check online, because even if the system that I mentioned not to be used, or not exactly not to be used, but not usually used anymore, but the system still stays the same. So let me check some fan coil units that there might be, or well, radiant panels that there might be. Excuse me. This is what a typical radiant panel will look like, right? So in the ceiling, the screen again. How about now? Yes. Okay. So this is what a typical radiant cooling panel or radiant heating panel in our case. I would not recommend the panel directly for cooling, but it will have these copper tubes going through it, and then it will have some kind of good thermally conductive element that will be on bottom of it. So when you look at it in a room, it will look something similar to this. It is not very different. Did I drop off again? No? Okay, it will, yes. Yes, it's showing up now, right? Yeah. So it will look something like this. It will not be very distinguishable as compared to, let's say, the lights. Okay. And if you have it in a T-bar ceiling, then in that case, it will even make it look just like a T-bar ceiling. So like over here, this is a typical example of a radiant panel. So all of these are radiant panels over here. It has a hinge on top over here. Once you drop it down, you will see these copper tubing in there. And these will be the heating hot water coming and circulating. So maybe one is inlet, the other one is outlet. So the water will basically circulate through it, and then that will create a radiation effect that will be transferred to the occupied area in the bottom over here, right? So on the other hand, let's talk about baseboard heaters. Baseboard heaters will look something like this. The perimeter heater that we were talking about, it will look something like this, right? So it will have fins in it. So externally, it will look something like this. It will be mounted down low on an exterior wall, because it is a perimeter radiant concept that we are using. It can also be properly camouflaged, and in there it will look something like this. There will be a copper tube which will be circulating the heating hot water through it, and then you will have the set of fins on top of it to maximize the area for heat transfer, right? So basically, yes, that is what we are talking about. Lawrence, does that answer your question or comment? Awesome. Perfect. Okay. So now I assume everyone has access to all of the files. Am I right? The links from the folder? Or do you guys need more time? Yes, everyone? Can I move forward? Huh? Sorry. Well, it's still downloading. Okay. Anyone else waiting for it to download all of the files? You are having issues, sir? Emmanuel, can you check if online everyone has access to it? So the files downloading, sir, at your end? This file's downloading? Not yet. It's downloading, right? And one more thing, I do mention most of you have a mouse here. Revit will work efficiently if you have a mouse. So try to avoid using keypad. Mouse is preferred for Revit, and there will be different commands that you can activate to the mouse, plus zooming in, zooming out will require a mouse. So if you do have a mouse, please use the mouse. So I'm in the meeting, right? So can we begin, or do we need to wait? We can start? All right. Okay, so I'll try to do this a bit different way. I do have a whiteboard thing that I would like to discuss. Is my whiteboard visible now? Is my whiteboard visible? No? Whiteboard? No. Can you make me like a co-host or something that I can share? Yeah. The other one, yeah, I might have logged in through two, right? What is not joined?
You are not in the Zoom.
Yes, I will log back. That not joined in the bottom. Okay, all right. So till I get my iPad set up for explaining how Revit will work like, till that time I will share the whiteboard on my screen. Okay, so we'll move further because this part I think I'll just explain what we would require for Revit to run. So basically, Revit is kind of, as I mentioned yesterday, it is a tool, a BIM tool that we use for collaborating with different teams. Okay, so what ends up happening is we will create one model, one Revit model. It will be a MEP Revit model. All right. And then we will have different parties of the project that will have their own Revit model as well, right? We might have an architect, we might have, let's say, a landscape consultant, we might have structurals, we might have civil. So all of them will have their own Revit models. Okay. What I've sent to you is a architectural Revit model. The zip folder that you downloaded right now, in the hospitals folder, what you have is a architectural Revit model. Okay. In most of us have used AutoCAD, right? So there is a concept for XREF, external references in AutoCAD, right? Where we link the architect's backgrounds into our files, right? Our files will be different, but the background will be from architect's file or structural file or civil engineer's file, so on and so forth, right? Just like that, we will link the architectural model into the MEP model, okay? Because we don't want to change anything in their model. That is a different team who will use their own standards, their own setup, whatever. But this, we are the owners of this particular MEP model over here. All right. So what I've sent to you is this. When working on an actual project, this is a dummy project for hands-on experience. But when you're working on a different actual project that will be built on ground, you will also have structural Revit model, civil Revit model, landscape Revit model, so on and so forth. All right. So right now what we'll be doing is we will be creating a new MEP model. Okay. For that, what I want you to do is go ahead and stop this one. Let me share. Okay. So in your start menu, you will have all of the options over here. There will be an Autodesk folder. That is visible, right? Yes. You have an Autodesk folder. Please click on that folder after you click on start menu. If it is Windows 11, it will be somewhere in between over here, the start menu. Over here, you will have Autodesk. Does everyone have access to Autodesk over here? And then you can simply click on Revit 2025. Make sure you click on Revit 2025. Don't click on Revit Viewer 2025. Should be Revit 2025. Okay. There might be a shortcut on your desktop as well. That is fine. You can use that as well. But make sure you're clicking on the Revit 2025, not Revit preview or whatever it is called. Don't use that one. That will not give you access to edit anything in the model. Once you open, your dashboard will look something like this. Is it open? This dashboard, everyone has it open? If not, please let me know. I can wait or else I'll move forward. But that will make you lose out on what I'm talking about. Has everyone open? I'll wait for 2 minutes. Online as well, please indicate you have it open. Yes or no? Everyone has this window on their screen? Yes? All right. Okay, let's move forward now. Now what we need to do is we need to create our MEP file or MEP model, right? Now what ends up happening is when you will start working on the Revit models again and again, you will have certain standards of your company or yourself. If you are a freelancer, you'll have some standards, right? You want the floor plan. Finally. Done? Okay. You can take care of it. But we will have standards that you will try to make your projects look similar based on those standards, right? So for that, you will create a template, okay? But we are lucky, Autodesk already provides us templates to begin with, all right? So what I want you to do next is, my screen is visible, okay. So in here, you will have options on the left-hand side where you have models shown over here. In that models, go ahead and click new. Models, new. Do you guys have access to this new project window now? All right, perfect. In here, you will see different types of templates under here. Okay. So if we were, let's say, an architect, we will start with this template. If we were a structural engineer, we'll start with this template. If we had just the mechanical scope under us, we will start with the mechanical template. If we just had the electrical scope under us, electrical template. If we were just dealing with plumbing, the plumbing template. Now, since we are doing all three, we are doing mechanical, electrical, and plumbing, we will use the system template. But before opening this, let's take a look at other templates that are available to us. Okay. So for that, when you click browse, it will open up a new window. It will open up a window for choose template like this. When you click browse over here, it will open up a choose template window. Can you click on the browse and open up the choose template window? Man, let's see. It's taking too much of your time.
So guys, is everyone flowing? Sorry?
You're not getting the?
Please, if you are not
Just, I'll come there.
Others, please ask for the
Yeah, please. Please, if you are stuck somewhere, even online, please raise your hand or drop your text. We'll make sure we resolve it.
So Engineer Maurice and Engineer Manuel, please provide us support too. No engineers instruct us.
But that's good point that you mentioned. Okay, there was one difference from what I was showing. So when we were talking about this drop down box, your options might be limited that you have, but no worries. What we are trying to learn over here is this other, clicking on browse will give you many other options. All right. And if you just have two, that's fine. The rest of it is coming from either this folder or one among the folders that I'll be showing. Okay. So everyone is on this particular choose template right now. Yes. How about this row? Everyone on this one? Yes. All right. You guys okay on this one? Anything? Yes. Go ahead. Let me know once you are done, then I will come forward because this is important stuff to begin with. All right, so looks like everyone is at the same page. So in this choose template, even if you were seeing just two templates when you drop down this box, all of the templates that are over here or any other templates that you require will be available when you click on this browse option. Okay. Over here, as you see, these are basically the English language templates. Okay. There are English language templates in SI system, kilometer, meter, second, whatever it is, right? And then you have the other systems as well. Okay. So many times what ends up happening is if there is a big Chinese company, they might be using the Chinese template because it's easier for them to follow their language, so on and so forth. Majority part of the world, we will be using either English or English Imperial. All right. There might be French, Japanese, Italian, so on and so forth. If in Rwanda or any other countries where the attendees are from, if you want to use this, please make sure that all of the other team members are also using the same thing, because we don't want your files to not conform with what the other team members are doing. Okay. And usually there will be something called as a BIM execution plan, BEP, BIM execution plan. Very important document. Very, very important document. I cannot stress it enough. This document is you have something problem? Okay, all right. This document is something that the architect will put together. Okay. That document will have information such as point of contact. Let's say from our team, Emmanuel is the point of contact. We are all on one team and Emmanuel will be the point of contact. From, let's say, structural team, there is one point of contact. So there will be contact information, first of all. There will be the level of design that is expected. We spoke about LOD yesterday, right? Level of design. What LOD is required from our side? Usually the consultants will be somewhere around like LOD 300. Contractors will be somewhere around 400. And then of course at the end, when everything is closed out as builds, we will be looking at LOD 500, level of design 500. That information will be there. There will be information regarding the base point of the project. We'll talk about base point in just some time. What type of base point do we need, right? So all of this information will be in the BIM execution plan, BEP, BIM execution plan. All right. Now over here, there are, as I said, different templates. For our exercise, what we are going to do is we are going to use the English Imperial template. Okay. So please go ahead and open that folder. English Imperial, English-Imperial. We have a problem. Why? No, that's fine. That's fine. This is just for the sake of hands-on experience. Be it SI or be it IP, at the end of the day, the physics stays the same, right? It's just the way we show it, not an issue. All right. So once we have that open, now we will have a lot many different options available over. Okay. What we need is the systems-default.rt. Is everyone able to locate it? Systems-default.rt. Click on it once and go ahead and click open. All right. That same thing will show up over here now, system-default.rte. Make sure create new project is mentioned over here. Don't click on project template, click on project.
Yeah.
All done? And go ahead and click OK. Now, once you hit OK, it will go into a bit of a thinking mode. And then it will get the file for us open to start working with. Okay. So everyone is on this particular. Yes? No? It's still loading. Yeah. Please let it load. It takes some time. Okay. One more thing. Till everyone opens the file, the model. One word of caution. If you have a Revit model, please do not go ahead and directly double click and try to open it. That is not the right way of opening Revit models. You have to go to the start menu, or if you have a shortcut, open up the interface for Revit 2025 or whatever version you are working with. And from there, open the Revit model. Do not double click on the Revit model and open it. It hampers the opening process. Plus, there might be some crashing going on from my experience. And even Autodesk will recommend this. Open up the Revit 2025 application. From there, open it up. As I was saying, on the dashboard, you will see models where we went to new. Instead of new, there was an open about. Like tomorrow, when we open up the same model, we'll go through that process. But don't never double click on the Revit model and try to open it. Okay, so everyone with me right now? Or is it still loading? Still loading? Done? Okay. All right. Now you might see window like this. you might see something like this. Okay. But the two main user interface that we require are the properties and the project browser. Okay. If you don't see it over here, in this area, most probably you'll have to interface and simply click on the properties over here. It is unchecked. When I check it, you'll have properties. And then next thing what we need is the project browser. Okay. Just a show of hands, how many of you have used Revit before? Anyone? Okay, 1, 2, okay, only 2, 3. Okay, that's good. Okay, then what I'll do is I'll go a bit more basic over here so that you understand what is what. This top portion over here in Revit is called a ribbon. Okay, so right now I have the view ribbon open. If I go over here, it's the architecture ribbon open. If I go over here, it's the structure ribbon open, steel, precast systems, so on and so forth. So when we talk about ribbons, these are the ribbons over here under the systems tab. Make sense? So for opening the properties and project browser, you will have the ribbons over the options over here under the view ribbon. Make sense? If you want to move around your project browser, simply click on it, hold the click and drag it wherever you want it. If you go to one option, it is showing me the blue, light blue transparent window. That is where if I hold and remove my click, that project browser will go. Okay. Now, as you start working in Revit, you will have your own preferences where the property needs to go, where the project browser needs to go. It's up to you. It's a user preference. Okay. For me, I like to have my properties on the left-hand side, the project browser on the right-hand side. Okay. Oops. Okay, so properties on the left hand side, project browser on the right hand side. If you want, you can have it one below each other, that is fine. Are we on the same page till now? Any questions? Online, any questions from you guys? Okay, I'll take that as a no. So we'll go move forward. Now, as I had mentioned on the whiteboard, we have this as the MEP model right now. Okay. What we need to do is we need to link the architectural model. Which is the architectural model? It's that model that you have downloaded through the link that you were sent. Okay. Make sure you have that model on your local drive, not on your cloud drive. And once you have the model downloaded, go to the insert ribbon over here. On top, you have the insert ribbon. Okay, click on the insert ribbon. And in the insert ribbon, you will have the link Revit option. Okay. Just a background information. You can also link CAD. It's not necessary you link only a Revit. Sometimes what ends up happening is the other parties do not have access to Revit models. They are working in CAD. Unfortunately, we will have to use CAD in that case. In this case, we have a architectural model. So we'll click on link Revit. Once you click on link Revit, you'll have the import/link Revit option available for you. Okay. Now what we need to do is navigate to the location where you have this RCCG proposed medical center.rvt. Okay, just navigate to it and single click it. Don't double click, single click it. Any help required? Is everyone up till this mark? Any help needed? Please raise your hands. Don't be afraid to ask me questions. Please raise your hands. We are here to resolve your issues. All good? Perfect. How about you guys? All good? Okay, all right. Now, the reason for the positioning, right? Open up the Google map. The reason I'm opening Google Map is to make sure you guys understand that we are actually working in real world coordinates when we work with Revit. So in this case, we are located somewhere over here, right? So let's say the project were to be built at this location. This particular location, the boundary of this location will have certain longitude and latitude associated with it, right? You understand, you remember longitude, latitude from primary school in geography, right? So every building, every location on earth will have a certain latitude, longitude associated with it, right? Same thing will happen with our project as well, right? So if the project were to be built over here, there will be some latitude, longitude that will define these boundaries. And based on that, the civil contractor will usually have a base point of the building. That is from where all the measurements will be taken. All right. For that reason, it is necessary to understand the positioning. Okay. Down over here in the import link Revit, you'll have positioning. This positioning information, you have various options for it. Okay. This is controlled by the architect. And that information is in the BIM execution plan. So always make sure you insist on a BIM execution plan from the architect or from the owner if there is a project management team. Yesterday we spoke about different parties involved in a construction. In that I had spoken about owner, and under the owner there was a project management team. Sometimes the client will also have the project management team driving the BIM execution plan. But I would say 90% of time throughout my career, it has been the architect who sets up the BIM execution plan. In that plan, you will have the option which needs to be selected. Okay. Since we don't have an architect giving us everything, what we will assume is it is auto internal origin to internal origin as our positioning. Okay. But again, since this goes into like later on construction, as I was saying, this is a collaborative effort. Even the contractor will be using the same model to base their position. So make sure you understand from the BIM execution plan where you need to have the positioning. In this case, simply click on auto internal origin to internal origin. This is on the assumption that we have an architect who has given us internal origin to internal origin. All right. Once you have that, click on open over here. All right. Once I click on open, it will show you this thing, that the model is getting upgraded from 2018 to 2025. The architect's model is getting upgraded from 2018 to 2025 Revit version. Every year Revit will have a newer version. All right. So whenever you're working on a project, everyone will need to work on the same version. Okay. In this case, it is a bit different since I've just downloaded it from one of the websites. But when you are in a project, the architect will use the same version, the structural engineer will use the same version, the landscape engineer will use the same version, so that everyone is refined and we don't have this kind of load link, upgrade link option again and again. This is just a time waste. If we were not to have, if we had the architect's model as well in 2025, this basically window would not have shown up. All right. So let's wait for some time. Are you guys with me on this one till this point? All right. Anyone having any issues till now? If you do, please please raise your hand. Please call me to your desk and we will try to resolve it as soon as possible. Okay, so once the model is linked, it will look something like this. Okay, what this is a link. So if I hover over the model, it shows me it is a RVT link. RVT stands for Revit, and it will give me the linked Revit model's name over here. So the name of that linked Revit model is the RCCG Proposed Medical Center .rvt is the model name. All right. One more thing, when you have the linked model in your Revit models, now what we currently have is a MEP model. We have linked the architectural model. Just like in AutoCAD, we freeze the layer that is for the XREF so that it does not freeze. We lock the layer for XREF so that it cannot be moved around. Same like that, we need to pin this element so that we cannot accidentally move it around. Okay, because we are trying to maintain a position, right? That internal origin to internal origin position we are trying to maintain. So if we don't have this linked, okay, if we don't have this pinned, there is accidentally we can move that model, right? For that reason, we need to make sure that we click on it, and then once that is done, it will have the manage ribbon that will be on over here, and in that you will have the pin. Okay, so once you click on pin, then there will be a small pin icon that will be showing up over here. All right, now if I try to move it, that model is not movable. Make sense? Can we go ahead and pin this model for now? Please let me know once everyone has pinned the model. Okay. So click on the model and then it will be visible over here. So click on the model and then you will see pin option over here. Once you have pinned it, then you will see this particular pin icon over here. Everyone following? Any help needed? All good? Pinned? Can we move forward? All right. Online, everyone is following?
Yes, yeah. Sure.
Awesome. Perfect. Now, the next thing we need to do is we need to copy monitor grids and levels. Okay. Is everyone aware what a grid is in a given construction project? No? Yes? No? Okay. So basically, I'll tell you, grids are usually used to identify the reference lines in a given project. Okay. So they will usually go like north to south or east to west. So those are the grids. They will be shown as a dashed line. The grids come in from the architect's model. So we need to copy monitor it from the architect's model. Along with that, we will also copy and monitor the levels. We will use the levels to create floor plans. Okay. So right now, once you have this model showing up, you will see icons like this. Okay. So this icon. This is something of a elevation view. Excuse me. This is a west elevation view. Like if someone is standing at this point, what they will see at this location. This is a north elevation view, that the north facade of the building is visible from here if someone stands over here. South elevation view and east elevation view. So what I want you to do is double click on this triangle over here. Okay, double click on that triangle. So over here, double click on this triangle that is for the south elevation. That will open up the south elevation view over here. Is everyone with me till now? Okay. So in the south elevation, if you check properly, you will have different levels over here. Level 1, yes. Any question? Sorry? Sure. So we have this is a floor plan, by the way. This floor plan is open, right? Once we link the model, the architectural model is visible over here. And then you have these 4 icons over here. 1, 2, 3, and 4. Okay. What I want you to do is go on the triangle that you see over here in the bottom of the screen and then double click on it. Everyone with me right now? Perfect. So what we are going to do is we are going to copy and start monitoring these levels. Okay. We do this for 2 reasons. First one is we want the floor plans to be created based on these levels. Okay. Like this is the ground floor or level 1, level 0, whatever you want to call it, right? On top of this slab will be, if this is level 0, that will be level 1. On top of that will be level 2. On top of that, level 3, so on and so forth, right? Something similar is going on. There is a floor at this location at level 2 over here. All right. So what we need to do is go to collaborate ribbon over here. Is it collaborate or this? Yeah, collaborate ribbon over here. And in here, you will see this coordination settings over here. Okay. Once you hover over that coordination settings, there will be more settings that will show up over here. Under the collaborate ribbon, coordination, and you have different options over here. Just try to find the copy monitor. Just let me know once you are done finding the copy monitor. Don't click on it, just hover over it. You want to find this. It will be in the collaborate ribbon. Collaborate ribbon under the coordination, and you will have 6 options over there. Excuse me. Everyone with me? Okay. You need help? No, this is the application. Yeah. We're not using the architecture. We're not doing architecture. That's what I was saying. So we go systems, referential systems, Okay, looks like we are on. Yes. Sorry. Properties browser. Go to the. So this is properties browser, right? Go to new. Yeah, the project browser. New. User interface. And project. Color. Okay, give me 2 minutes. I'll explain that. All right, so looks like everyone is at the same pace. Now go ahead and click the copy monitor over here and click on select link. Once you click on copy monitor, select link. Once you select link, you will get an option. By the way, once you activate a command in Revit, on the bottom left over here, it will give you the option of what is the next thing that you need to do. In this case, I think so it is saying pick Revit link over here. Okay. So once that option is selected, the Revit link that we need to select is the architectural Revit link. So go ahead and click on that architectural Revit link. It will even give you a blue box around it. And once you have it clicked, your ribbon will change a bit. All right. Click on that particular Revit model, and then your ribbon will change on top over here. All right. Once that is done, click on copy. All right. Once you click on copy, this multiple checkbox will show up. Click on that multiple checkbox. Okay. Now, as I mentioned, what we need to do is we need to copy and monitor these particular 5 levels. So what I want you guys to do is start with your control button held on your keyboard. Start selecting every level that you see over here. Just 5 levels. Don't select level 2 and level 1 over here. I'll tell you in a moment why that is the case. Once you have selected all of those levels, then go ahead and click finish over here. On top right next to the multiple, you'll have finish. Once that is done, in the top over here, you will have the copy monitor. Please pay attention over here as well. On the ribbon, once you have selected all of these over here, you will have the copy monitor ribbon. It may be hidden if you are using a smaller resolution monitor. Once you come back to copy monitor option over here, there might be 2 arrows over here. Click on that, select copy monitor, and click finish over here. Okay. Do you want me to show it again?
Yeah.
Okay, all right. So I'll do a undo. Okay. So I'm showing it again from the start. We are in the elevation view, in the south elevation view. Then under the collaborate ribbon over here, we have the copy monitor. Click on select link. All right. Click on select link. After that is done, click on the linked architectural model. It will even give you option. It will even give you a pop-up saying like this link is what we are selecting. All right. Once you click on that, the interface for the ribbon will change over here. Once that is done, click on copy. Click on copy. Click on multiple over here. With your control key pressed on your keyboard, select these 5 levels that are visible over here. Once you are done, leave the control key and click on finish first. After that is done, go back to the copy monitor ribbon over here. Okay, if it is not visible, it will be visible when you click on these 2 right facing arrows over here. Come back to the copy monitor and click finish. Are you guys following? I'll come to everyone's desk and show it. And online as well, if you guys are not following, please let me know. I will guide you guys as well. Okay. So, any help needed? So that, yeah, since your resolution is bigger than my screen resolution, then that will be for copy. Click on copy one. Click on finish. so I'm sharing my screen again. All right. So now that we have copied and monitored the levels over here, what we'll start doing is we'll start creating the floor plans, right? Because we require floor plans to show our equipment, correct? To show our ducting, to show our piping, so on and so forth. So for that, what we'll do is we'll go to view ribbon. Okay. Under the view ribbon, you will have this icon which says plan views. Okay. Click on the plan views drop down box over here. All right. You will have different options now. You might have a floor plan in your project. You might have a reflected ceiling plan in your project. There might be structural plan. Well, structural is not what we will deal with very often, but the floor plan and the reflected ceiling plan is what we'll use day in, day out. Right? So for our reasoning, for our work, we need level 1 and level 2 floor plan setup. Okay. For that, view ribbon, plan views, click on floor plan. Excuse me. So over here, we'll talk about it. So again, view, plan view, floor plan. That will open up this new floor plan window for you. Okay. Now over here, if you don't see level 1, level 2, the reason is because you have the do not duplicate existing views. This means that there are already views based on level 1 and level 2 that are already in the model and they don't want us to duplicate it. Once you uncheck it, all the levels will show up even if they are already created for a floor plan. Okay. What we need to do is create the floor plan level 1. All right. That will give us this floor plan. And then the other floor plan that we require is for level 2. Again, level 2 is not visible. I'll simply uncheck this. Level 2 will be visible over here. Click on level 2, click OK, and your level 2 is available over here. So please let me know till level 2, everyone has access to 2 floor plans, level 1 and level 2. Are we talking about bio break or are we talking about half hour break?
Yeah, you have to
Half hour break?
Yeah.
Yeah, because it is 5:30 already. It would be better to have it. Okay. Because then I think so after 6, then I'll just sit for 2 hours because there is a lot.
No problem. No problem. Isman, can we, how many minutes can we use for your break? 15 or 5?
That's up to you. We can use 15 also, we can use 30 as well. But the syllabus 15 is better, I think, so, because there is a lot to cover.
Yeah.
All right, so everyone has access to level 1 and level 2 floor plans. Yes, yes. Yes. Online, please let me know if everyone has access to level 1 and level 2 floor plans. Okay, thanks for the feedback from the team online. Okay. Gorky, good over there?
Yeah.
All right. So if that is the case, let's move forward with the floor plan. So now on a given floor plan, if I can have everyone's attention, on a given floor plan, there are rooms, right? The rooms have an associated room number as well. So basically what we are trying to do over here is assign a room tag which will have the room number and the room name associated with it. This information is fed into the architectural model, and we are getting that information from our linked architectural model. Okay, so this is our linked architectural model. What I want you to do is go on to the tab which says level 1. And by the way, if you're not able to find your tab, simply drop down in the switch windows over here and you'll have the tabs over here. Okay, so when you hit level 1, you'll have the level 1 floor plan over here. What I want you to do is go into the annotate ribbon over here. Annotate ribbon. Everyone with me? Okay. And in the annotate ribbon, you'll have the tag over here. And in that, you'll have a room tag. Once you click on the room tag, Revit will say rooms are not currently visible in this view. A view template is assigned to the view in order to make the rooms available. The view template needs to be edited or removed. So if you go to manage view templates over here, this is something called as a view template. Okay. As I initially mentioned to everyone, every engineering company or every engineer will have their own standards by how they want to show their floor plans. Okay. So Revit gives us the ability, and this is a very big time saver for all of us engineers, that a particular view template can be applied to all of the floor plans that we are using, all of the HVAC floor plans we are using. Okay. So that view template we are talking about is the mechanical plan view template. Okay. This view template is also accessible from the properties menu. When you come to this particular floor plan, when you scroll down over here, you will have the identity data, and under that you will have the view template mechanical plan. Once you click on that mechanical plan, the same window will show up. All right. In case it is blank, it is selected none over here. That means your view does not have any view template assigned to it. Okay. When you are working, so usually when the work process is set up, what I recommend everyone to do as junior engineers is to create two set of plans. There will be one working plan, and then there will be one sheet plan. The sheet plan is the one that we will show on the sheets. The working is the one that we will work on. Okay. So what we show as a presentation on the sheets that we will be printing needs to be properly coordinated, right? So that will require a view template. In that case, you can use a mechanical template or any other view mechanical template or any other template that you want associated with your project. Once you click on mechanical plan, as as we clicked on room template, room tags, it showed us this. Clicking on yes over there will make sure all the rooms are now visible over here. What is going on? Just let me do one thing. Let me change this to mechanical plan. And in the mechanical plan, okay, going back to the thing. Once you click on rooms over here, it will tell you that the rooms are not visible. And even with your cursor, you won't be able to assign any room tag. So for that reason, we will change the view settings of the mechanical plan view template. With the mechanical plan selected under the names, click on the VG override models. VG stands for visibility graphics. Okay. There will be a visibility graphics for the model, for the annotation, for the analytical elements, imports, filters, Revit links. Click on the edit for the VG override model. In here, this will be the visibility graphics override for mechanical plan template that we have over here. Can you please click that? Click on rooms. It will take you to the assigned view template. In the mechanical plan view template, you will have the visibility graphics override model. Click on edit over here. It will bring up this particular overrides window for you. Everyone with me till now? Okay. You guys okay? How about over there? Everyone okay? Gorky? Good on that side? All right. Okay. So over here, what I want you guys to do is, first of all, in this model categories, scroll down and select rooms over here. Okay. The rooms basically are not visible. Now, rooms is a concept which is invisible technically in Revit. Okay. There is a volume of the room that will be available for us, but there will be no physical entity per se assigned with that room, right? For here where we are sitting, the interior volume is a room, but it's not technically visible to us. This is the wall, this is the slab, floor, but this entire thing, the interiors is the room for us. So click on rooms over here so that rooms are applicable, are visible, and click on apply and hit OK. We'll come back to the assign view templates again, hit apply and OK. And let's try to tag the rooms now. Okay, looks like it's still not visible. If this is the case, just a minute. If this is the case, let's go back to the view template. Most probably the views, the rooms are not visible in the architectural model. For doing that, in the mechanical view template, go to the VG overrides Revit links. In here, the Revit links tab will open. What we were doing earlier was in model categories where we had turned on the rooms over here. Now we are in the Revit links. And in the Revit links, this is that same link that we are using for copy monitoring the architectural model. In here, you have by host view. Click on that. It will open this Revit links display settings for you. The first tab is basics over here. Okay. In the basics, make sure you click on custom. Okay. Once you click on custom, come to the model categories again. Over here, you see by host view, drop down that box and select custom over here as well. Now scroll down to see if the rooms are hidden over here or not. So rooms are not hidden over here. What is going on? Okay, if that is the case, let's move on to level 2. We'll talk about level 1, why it is not showing up as tag. The room tags are not available over here as well. Okay, so since we are getting into the issue that the room tags are still not assigned, what we'll do is we'll go one by one and start naming the rooms over here. Okay, so what we'll do is we'll assign the names to these rooms, go to annotate ribbon and go to text over here. We'll call this room number 1. Then we'll copy this room number 1 over here. Then we'll call this room number 2. We'll call this, you can even hit control on your keyboard and click drag. Sure. Annotate. In the annotate, you'll have the text over here. Okay, click on the A and then that will give you the text option over here. Okay, so this is not the best way of doing it, but to make sure you understand the concept. So this is room number 1, room number 2, room number 3, room number 4, so on and so forth. All right. So now what we are trying to do over here is trying to start with the heat load calculation. For doing the heat load calculation, we need to make sure that we have the rooms properly labeled, because what we are going to do is in this spreadsheet that we had, we are going to add the room numbers. Okay, over here we are going to add the room numbers, and that is the reason why we are trying to add the nomenclature for a given room. All right, so let's do one thing. Let's add the room numbers to these 4 rooms, 1, 2, 3, 4. Then I think so we have a break. Right now it's fine, right? Okay, let's add the room number for 1, 2, 3, and 4. Once that is done, the next step for us is to get the heat calculation started for each and every room, our ducting, our equipment, right? So let me know once you are done with tagging room number 1, 2, and 3, and 4 on level 1. Then we will begin with the break. Just give me a thumbs up once you are done so that we understand. Even online, if you guys have any questions, please feel free to drop them in the chat box. Has everyone labeled their rooms? Online, does everyone follow? Any questions online?
No question.
No questions online?
But they are
Good. But they are following. That's good. We have one command that was not finished. That is the reason why the next was. Makes sense. Okay, all right. Let's get started. I'm happy that there is feedback now. It gives me a proper direction. I'll make sure that I lower my pace a bit more so that I understand. We have a mix. Just I'm unmuted, right? No, I'm unmuted. Okay. I mentioned that that I understand that there is a mix now in the attendees, be it online or in person, that some of us have touched Revit first time and some of us are kind of beginner to intermediate course. To answer to what Mr. Tokes is saying, yes, Tokes, you're correct. We don't have the architect who has set up the rooms properly. So what we'll do is we'll do that tomorrow. Let me set up the models and we'll get it updated. All right. So now that we have labeled the rooms, let's go ahead and begin the exercise for let's begin the exercise for heat load calculation. All right. So I'll share my screen. I'm sharing my screen. Ready to share? Okay. All right. Go by room number 1. Okay. Since most of us in the room as well as online are engineers, specifically mechanical engineers, we'll take a look at something that is very basic, heat transfer, right? HVAC, the fundamental is temperature difference between two surfaces, the heat transfer as much as possible. If it is hot outside, we require AC inside, right? Air conditioning, cooling inside. If it is cool outside, we require heating inside, right? So now what we'll try to identify is how big our HVAC system needs to be in this case, all right? That will dictate what type of equipment that we have studied already we need to use. That will dictate how big our ducts need to be. That will dictate how big our chillers, cooling towers, unitary equipment, whatever it needs to be. At the end of the day, the load will be the same because we will be using the same model over. Okay. So let me give you a rundown of what this spreadsheet is about. Okay. This spreadsheet will fundamentally work on this formula over here of resistivity of an element, the resistance to thermal heat transfer. A is the area. Let's say if we are talking about this area over here, this wall, right? The entire wall is not opaque. Some of it is transparent with glasses, right? So we have glazing in it. So that will have a different U value as compared to what the column might have. Okay. Then we will talk about the temperature difference. The temperature difference is basically the room set point. Yesterday we had done that small exercise of recommended room temperatures, right? That as compared to what you have outside. And sir, yesterday you did mention regarding the temperatures in Kigali, it is different, right? In Kigali, it will be different. So if you scroll down on the spreadsheet over here, we are going to identify based on what we have in the outside air temperature. We are trying to get that in, right? That will also come into picture, right? We will figure that ambient outside. We'll take an example of Kigali, or you can take any example, that's fine, wherever you want your project to be. So your outside ambient, right, we will take that from the ASHRAE Meteo website that we discussed yesterday. All right. Now this spreadsheet has different tabs, 1 and 2 tab. Okay. We'll have 1 tab for every room at this point of time. Okay. To make sure we understand the exercise properly. All right. So now what I want you to do is, let's go on to Calc 1. Okay. And we will rename it to, can you all open this particular spreadsheet, please? It's in the same link. Everyone has it open? Okay. So over here, we will rename the, if you're not able to double click and rename, there will be an enable edit button. Please click that and let's call this room number 1. All right. So this is the spreadsheet for room number 1 that is over here. Is everyone with me? Okay. So next that we have identified our room number 1, let's take a look at the spreadsheet one by one. What all data we require from Revit into this spreadsheet. Okay. What we require is the solar gain due to the glass. What that means is, if you have a transparent window, okay, without any tint, that is capable of transferring more heat into the indoors as compared to if there was a tint. Make sense? So we have window, right? This window. If this window is totally transparent like our glasses, it's totally transparent, right? It does not absorb, well, it will transmit 99% sun rays from outside into inside. The heat transfer in that case will be more as compared to if there is a tint on the window. If it is a blackish window, right? Like our sunglasses, it's blackish. So not a lot of heat gets transferred indoors, right? Same thing now, that is for the glass. What if we have a wall? That will transfer even less, right? Because it is opaque. This is transparent, right? So we are talking about the U values over here in that case, right? Yes. Yes, yes. At the end of the day, this is in degree IP system. You can enter the data in IP, that is fine. But when you are converting it at the end of the day, CFM, you can just convert it to meters per second. At the end of the day, the basics physics stays the same, be it in IP or be it in SI. Wattage, the unit will stay the same, be it 50 hertz or 60 hertz, be it 230 volts, be it 480 volts. Equals to V equals to IR will be constant, right? Uh-huh. Absolutely, yeah, that's totally fine. That's totally fine. And well, this is a spreadsheet, so in here it might be a bit tedious to go one by one and change everything to square meter. But there are advanced software like I heard someone using Carrier Hack, right? Train Trace, ISV. There it's just a click of button. All right. But for our understanding, it is very simple for us to have this in our scenario. But at the end of the day, again, the basics are going to stay the same. I know this is a valid reason. I also work in metric system as well as IP system. When it comes to metric system, my clients in Dubai and Middle East and Europe push back on me to get that answer. But if you have a software, it's easier. Over here, you just need to do some conversion before relaying it to them. All right. Okay. Then we are talking about glass, right? And after that, we are talking about the walls and the roof. Okay. Just like the walls, the roof is also supposed to transfer some amount of heat, right? At the end of the day, right? So we'll enter the information for the walls and the roof over here. In the end, we will take into consideration if there is any all glass building, then that all glass building will go over here. Partitions and ceilings usually don't come into picture because there is already heat transfer considered through, let's say, the slab or the roof, so on and so forth. Okay. The interior spaces, like that is an exterior wall. This is an interior wall. The interior wall will be called a partition. Okay. Since the temperature is regulated in this area, if there is an area right next to this, which is an interior area, that will also be regulated because this is kind of a buffer zone for that area. So that area is not exposed to extreme conditions that we have in the outside. Make sense? Understood regarding the concept for partition? Next is regarding the infiltration. We spoke heavily about pressurization yesterday, right? You have more pressure in this room if the inlet CFM in this room is more than the outlet CFM. That means the air will be pushed out from the infiltration, the cracks between the wall and the floor or wall and the ceiling. Make sense? Next is the internal heat. We as human produce heat, right? We have metabolism. Once we have food, then the food gets digested. We perspire. That will also contribute to heat, right? Along with that, interior loads, the projector right now is emitting heat because of its lamp. Our laptops, the chargers are emitting heat, right? The light fixtures are emitting heat, right? Nowadays, the LED light fixtures are becoming very energy efficient, like 99% energy efficient, I would say. That is why they don't emit that much heat. But in the yesteryears, we had those fluorescent lamps, incandescent lamps. Those used to get hot, right? And those were actually used interiors as well. So the HVAC loads, when they were designed, needed to take into consideration those incandescent lights as well. But right now it's not that much. Okay. So lighting equipment, any other equipment, like we will talk about some other equipment as well in the field of hospitals. Now, if you take a look over here for the glass and the walls, you have north abbreviated N, northeast abbreviated NE, east, southeast, south, southwest, west, northwest, right? Same thing will happen with the walls as well. All right. When you get your project, please identify the difference between the true north and the plan north. Okay. What is a true north? If I go to Google Maps over here, this is the true north. Okay. It's not visible in this, but there is possibility that the architect, if he or she is designing this particular building over here, they will just align it so that it is properly 180 degree, 90 degrees to the plan. Okay. And now in this case, if we are identifying the northeast, okay, this will be the northeast face, right? Over here is the northeast face of it, right? This will be the southwest face of it. This will be the southeast face. Again, northeast, northeast, northwest, right? Please make sure you understand properly how the building is oriented. The sun rays coming from southwest are always the highest. Okay, specifically during summer seasons. All right. So if you have not considered these particular directions properly, your heat loads are going to be different, which might affect your HVAC systems running overtime. Okay. That might also come back biting to you when the owner says your AC that you designed is not taking care of the loads. What do we do? Right? In that case, it is very important for us to properly identify this. Okay. And okay, yeah, one more, since we are on the topic of the Google Maps. The other day I was having a conversation with a very stalwart, you can say, in the field. So what he explained to me, and the reason why I also push back on systems like VRFs and whatnot, is because there is a lot of leakage. It has become very common in the market to have leakages in the VRF system. Okay. So on an average, 1 ton of refrigeration capacity VRF will have around like 11 to 12 kg of refrigerant 410, 11 to 12 kg, okay? 1 ton, right? So if you take a look, leakage of 1 kg of that refrigerant is equivalent to driving almost 1500 kilometers of diesel vehicle, okay? To give you an idea of how that affects, so this is Rwanda, right? This is the westernmost point of Rwanda. Yes, right? Westmost point is somewhere over here. So from this point, right? What is going on? From this point to the westmost point, somewhere over here, westmost, eastmost, right? So we'll check if Google Maps gives us that direction. But from east to west, it is 574 kilometers, right? So leakage of 1 kg of your refrigerant is equivalent to the CO2 that will be produced by a car running on diesel for 3 times the length. Oh, no. What is going on? 3 times the length of this one. I know it's went from another country, But that is the impact we are talking about. Going from one point to other point, coming back and coming back. That is the impact we are talking about for VRF leakages, right? So of course, it doesn't seem a lot to us, but when we come to the grand picture of humanity, this is what we are talking about. Do you understand the impact that we are talking about? I know this is not related directly to the course, but I just wanted to give everyone an overview of how big of an impact it happens if there is just 1 kg of refrigerant leakage.
Does it mean because it has
Just a minute.
those guys do they have a greenhouse?
Greenhouse effect. Exactly. That is what we are talking about, right? So the carbon will capture heat, it will keep it in the atmosphere itself, and then that will raise our temperatures. So the climate change, temperature increase. This is what we are talking about, and that is where the Kigali Convention that happened to phase out the chlorofluorocarbon and hydrofluorocarbon was the essence of this. That is why we have outdated that, and we are coming towards more and more natural refrigerant as well. So, yes,
That's confused.
no, not at this. Psychometric charts will be more focused when we are doing a refrigeration samples. Right now, we are trying to identify how big our refrigeration system is. But yes, that is the basics where it comes from. But for this exercise, we want to nice view. All right, for the team online, the question in the house was basically, are we going to have any psychometric calculations for this table? Not directly. That psychometric charts are used for more of designing of refrigeration system. We will be selecting the refrigeration system over here. All right, so this is what is happening on the left side of the chart over here. On the right hand side, if you see, as I explained earlier, we will enter this information from the ASHRAE Meteo website. We are talking about the CFM ventilation. Okay, so instead of the CFM ventilation, we will be talking about the air changes per hour that we spoke about yesterday, the minimum ACH that we are talking about, right? Total ACH and minimum ACH. So this is where it will come into picture. Infiltration, again, you have the cracks, basically the cracks between the exterior wall and the floor or ceiling. That is what we will take into consideration over here. And basically, at the end of the day, we will get the MBH value or kilowatt value. It can also be corresponded with a tonnage value for the HVAC system. So each room will have its own cooling requirement. And based on that, we will be designing our systems. Is that clear? Sure. Any questions? Any questions online? Okay, all right. Okay, so what I want you to do now is, now that we have named this room number 1, what we will do is we'll start entering this information one by one. Okay. For entering this information, area we will get it from the model itself, the Revit model. This delta T, we will take care of it with respect to the numbers that we'll be entering over here, because there will be a delta T. Delta T means difference between two temperatures, outside temperature, inside temperature. And the U value, we will talk about another ASHRAE code, ASHRAE 90.1, which is an energy efficiency code that will be required for calculating how much BTU per hour or kilowatt is required for a given room. Make sense? Okay, let's move ahead with the first room now. I will show you an example first. You will calculate the areas, all the areas for the glasses first, for the room number 1. Okay, glass means window, any door which has a glass in it that is facing outdoors, not indoors. Okay. Now let's go back to Revit. Room number 1. Okay. Now what we will consider is, we'll consider this as the true north. So this is the north facade, south facade, west facade, south facade, and east facade. Okay. Facade means the walls and windows facing the outdoors. Make sense? So room number 1, this is a window, right? Everyone is used to reading floor plan. This is a window, right? Can you tell me which direction the window is facing? West, right? Now we will have this column that we'll need to fill over here. Okay. Rest of the data you can go ahead and delete it, because that's just from some example over here that will enter. West. Okay. Now going back to the Revit model. Now over here in Revit model, you can measure stuff. You see on top over here, there is a small scale. It says measure between 2 references. Okay. So we'll measure it from here to here. Why? Because this is a window pane over here. If you see system glazed, glazed means it's a glazing. Glazing means glass. All right. So there are 2 ways of doing this. Either you can have the area answered from here, or you can simply go ahead and try to measure it. So this is somewhere around 3 feet 8 inches. All right. And now this is just the width, but we require the area of the particular window, right? So for that, we also require the height. Width into height will give us the area of that window, right? Now there are 2 ways of doing this, right? We were talking about elevations. Why do we require elevations? Going to this elevation will show us that window height over. Make sense? This is the same pane that we were talking about over there. There's a curtain wall. Okay. This is the same pane that we were talking about over there, right? So now the width was somewhere around 3 feet 8 inches. The height is somewhere around like 5 feet 6 inches. Make sense? All right. Now going back to the, we can take out a calculator as well. Okay, so we had 5 feet 6 inches, that is around 5.5, and then we have 12 inches in a foot for reference. Okay, and then we had somewhere around like 3 feet 8 inches or something, so around 3.75 or something. So the total square footage of that room that we are of the glass that we are looking is somewhere around 20.625 square foot, right? That 20.625, let's make it 21 even, that will come over here. Is that making sense? No? Yes? Sorry? No? Okay, all right. Let's go back to Revit. All right. We were on level 1 over here, right? Talking about room number 1, correct? There are 2 external surfaces, 2 facade walls to this, right? This one and this one. It is facing outside, right? These walls are not facing outside. These walls are facing inside, right? The surfaces that these walls will see will be either this surface or this temperature or this temperature. Both of those temperatures are not facing to the extreme conditions that are outdoors, right? In that, first we are talking about glass, right? For the glass, we will talk about this particular window pane over here, right? This is a glass. Once you go to the west elevation, it will show you that glass over here on the first floor, right? It's the same glass. You can even select that glass over here and then go to the elevation to see that you have selected it over here, right? On the top, you will have this small ruler which says measure distance between 2 references. Click on it and then you can go from one point to the other point. All right. So 3 feet 7 inches, you can just go to Google and check. how much that comes to decimal feet. And over here, we were looking around like 5 feet 6 inches. All right. So going back to the calculator, we did 5 feet 6 inches into 3 feet 9 inches, whatever that is. And then that comes up to 20 feet 20.625. And then we have just upsized it, rounded it up to 21 square foot as the area of that window. Is that making sense? Sure. Yes. Just a minute. Only the glass. Only the glass, because we are talking only about the glass will have more heat transfer as compared to the wood. We'll talk about that as well sometime, having the framing and the actually yeah. Okay, understood. Okay, yeah.
So, I just in example, how can you select
Only?
Select the windows.
Yeah, just hit tab on your tab on your hit tab. Hover over that reason. Hover just over it. Just hover over it. Hit tab. Click. I'll teach that as well. All right. So there were some questions in the room for the folks that are online. First of all was that some of the team members in the room have this particular symbol, the elevation symbol in the room. They have something like this. If that is the case, simply on your mouse, left button, click, hold, select the square and the triangle and move it to the location that you need outside the building. And then when you double click it, your elevation will show up as is. One more time. So let's say it is inside over here, right? On your mouse button, left mouse button, click, hold, then it will take a selection box. Select everything that you want to move. Then once it is moved, either you can go up over here for move, click on it, click a reference point to move, and then move it to the location you want. If that is not the case, select everything, click, hold, drag outside. Is that making sense? Okay. There was one more question in the audience. I was selecting this particular window pane over here. How do we do it? For doing it, if you have a linked element, right? Like let's take an example of this particular window pane over here. What we'll do is we'll try to hover over it. Don't click over it, hover over it. On your keyboard, hit tab. Don't click and hold tab, just hit tab one time. It will get selected. Once it is highlighted, click on your mouse and then your particular glass will get selected. One more time. We'll do it with some other element this time. Let's say we have this lavatory over here. Okay. This lavatory comes from the linked model. I hover over it. I tab and then I click. It selects the particular element for me. Yes. Any other questions? All right. Okay, so everyone is clear till now? Yes? Yes. Sure. So whenever this happens, you want to change this, you can simply select start with application. So over here, first of all, this is the manual tool that you can measure gain of here. Right? Gain of now, modify, then you hover over there. You hover over there. Click then click your next button. But right now I see you don't have your properties. So click on the properties, make sure you have the properties visible. Make sure you have your project browser visible. And you can move those project browsers. So, does that make sense? Then you can simply go to this creation tool and type your steps. All right, so everyone with me till now? Yes. Okay, so we have a question online. We haven't copied copy and monitored the grids. I think we only did the levels. Yes, I noticed that there are no grids in the architectural model, or is there? Let me check and confirm once. If there is, we'll do the grids as well right away. Yeah, looks like there is no grids to monitor. Mr. Tabal Cult. So that is the reason why I did not push for the grids. But yes, just like we had the levels copied and monitored, you can have the grids copied and monitored as well. Grids will look something like, I'll show you an example of a grid in some time. But the question, one more question in the team was, in the online team was, can we have the measurements properly shown all the time? So yes, if you come over here on the top, you have the align dimensions. In here, you need to select the location where you want the dimensions, and then you can have the dimensions properly labeled. So this is how you will, what is going on? Just a minute. So these are the dimensions for the height, and this will be for the width that we are talking about. Right? So that is how you will display the dimensions. All right. So accordingly, what we will do is we will now take a look at the walls for the room number 1. Okay. Again, there are just 2 walls, exterior walls for this room number 1. 1 window and 2 exterior walls. Okay. So this is the first exterior wall and this is the second exterior wall. Can someone tell me which direction this wall will be? North, right? How about this wall? West, right? So now again, talking about the dimensioning, we'll take the exterior point somewhere around like 13 feet 4 inches. Then we'll go to the north elevation. We are talking about this wall over here. Now, if I zoom in, zoom out, it shows me the interior wall over here, the partition over here. But it does not show me exactly how till where it can be, because I need to go in here and do the calculation for the exterior wall. It is snapping to something, but we don't know what it is snapping to. All right. For that reason, we need to have a section view. All right. Till now, what we were looking at is a floor plan. Now we will talk about a section view. Okay. How do we add a section view? Let's go to the level 1 floor plan. Over here, you have the option on the top. Over here, section. All right. If you don't find it over here, you will find it in the view, in the create section of the section. All right. Once you click on it, it will again give you the option. It is ready for doing the section. Simply click on one side. That will be the section that we are drawing right now. Okay. The section looks up to north, right? And this will be the extent till where the section is showing up. One more time.
Yeah.
View ribbon, section. If you want a section that is north-south, simply click and click over here, 2 clicks, right? In the same way, if you want sections on the east-west, click, click. Does that make sense? So this section is basically looking upwards. This section is looking towards east. Following till now? Do you want me to do it again? Anyone? Any questions? Okay. So now what we'll do is, now if you see, we want to measure the length of this wall actually. But my section is looking down, right? For flipping the section, you can right away do a right click and flip section. It will go on the other side. Or you can click on these 2 icons. You can click on this icon that says 2 arrows in other direction to flip the section. If you click on it, it will flip the section. Same function. Let's flip the section again over here. And then right click on it and go to view. That will open that section view for us over here. All right. If you want to do, you can double click over here as well. It will take you to the section. All right. Now, if I select this wall over here, I hover over it, I hit tab, and then I come to the level 1 floor plan over here. This is that same wall that we had selected, just as a sanity check, right? Are we measuring that the correct way? Now I go back to that section view over here, and then I start measuring the wall. right? From here to here, 13 feet 2 inches. All right, that is the width of the wall. Let's talk about the height of the wall. From here to the floor, looks like this is the floor. It is 9 feet 10 inches. Understood till now? Okay, so let's talk about the calculations now. 9 feet 10 inches, somewhere around like 9.8, right? Into the width of the wall that we had, 13 feet 2 inches, that is 13.16, I think so, something like that. So the wall, the north wall that we are talking about over here is 128.968. We can round it up to 129 square foot, right? That will go in the wall north, 129 square foot area. All right. Are you following till now? Are you guys sure? I see a lot of blank faces. Are we sure we are following till now? Yes? Everyone understood the concept of section? Because elevation will give you the elevation from outside the building. When you're working inside the building, you'd require a section. So it is very important that you understand how a section works. Flipping the section, rotating the section. I'll show a rotating section as well for you. Over here, when I go to the level 1 where we have the section view, if I want to rotate it in some direction, simply click on the section view. On top in the modify ribbon over here, so modify ribbon over here, you'll have the rotate option. Now over here, this point over here, it's the point through which the section can be rotated. Reference point you can call it. You can simply click and drag it and try to place it at the location that you want. In this case, I have placed it in the center of that section. Once that is done, you see this particular line that is revolving, right? For that line, you simply click on it, and if you want to give an angle, you simply enter an angle over here, and that angle is assigned to that particular section. That section is at an angle, because sometimes there will be parts of the building that are aligned to 180 degree or 90 degree, right? Make sense? This will also be in the same way for, let's say you're trying to draw some annotation elements. Let's say you're trying to draw some detail lines. Okay. Detail lines. We have detail lines over here. If you have one line, you can again rotate it with whatever axis you want accordingly. All right. So trying to explain the rotate command just like we had used the move command over here. Make sense? Any questions till now? Sorry? How to visualize the section? Yeah. Okay. So let's go back to the, so for the folks online, the question was, how do we visualize or how do we activate the section view, correct? So over here we have one section, right? So over here, there are two types to activate that section to see what that section looks like, okay? First is right click on your mouse button. It will bring up this particular menu over here and you click on go to view. That will take us to that view of the section view. Okay. The other way is you have this this head of that section. Just double click on it and it will take you to that view. Make sense? Okay. All right. So now what I want you guys to do is try to identify the area of this wall over here. Okay. This one?
Any certain angle that you wish to.
Sure. So click on the section, right? On top, you will have the modify, whatever you select, right? Now, if you select this menu is relating to this section. Now this menu that you see is relating to this section. It cannot happen that I want to rotate this section and I have selected this segment, this section. It's not going to happen. It's applicable to this section only. Now over here, you will get a reference point over here. All right. You can left click on your mouse, click, hold, drag, and try to snap to one point that you have. Once you click on that point, that reference point will move to that location. Now, this line is the line that you want to have for rotating. You can either click on that line and it will snap as well. Right now it's snapping at 90 degree as compared to that section. If you want to have it snap to this one, it will snap to this one as well. So now I click on it and then either I rotate it and check how much it is being rotated, or if I have some unique number, then I'll just type it in my keyboard. 22.5. Now this section is rotated at 22.5. And the rotate command is applicable to everything. You can rotate a duct, given it is not connected to anything because that will remove its connection. But you can rotate a line, duct, diffuser, lighting, fixture, as long as it is not hosted on any wall or something. This command is applicable to all of the elements. All right. Okay. Let's talk about this one. Now, first of all, go ahead and draw the sections. And then I want you guys to try to identify the square footage of this wall over here. Okay. This wall, particular wall. And let me put a twist to it. I want you guys to check the effective area that will be exposed to the sunlight. Okay. Area of the wall, the effective area of the wall that is exposed to the sunlight. The opaque area, to give you one more hint. The opaque area, huh? The folks online can type their answers in the chat box as well. Any answers? Okay, so we measured the area of this wall, correct? Right now, that we have entered in our spreadsheet over here, 129 square foot, correct? Just like that, we have another wall that is west facing wall, right? So we need to have the square footage of that wall entered over here, correct? So now that wall is this wall over here. I want you guys to identify the opaque portion, square footage of that wall, right? That window is transparent, right? This wall is opaque, right? So I want you to identify or find the opaque area of this wall over here. Yes. Yeah, you can tell me. We'll type it out. Yeah, you can let me know. We can type it out over here. Do you have an answer? Sorry.
Yes, I'm also going to answer it, but I want to identify it's a problem solving test, right? So we try to do our best.
Any answers?
So just like we had for the north work, we measured length, right? Similarly, we need to measure length. But only for the opaque, not for the transparent.
Any answers? Anyone from online? Sorry? 70, 70, 78 square foot, right? All right. 78. Okay. Anyone else? Maybe we'll take two more answers. Anyone from online wants to give it a try? Let's check. Let's check. Any more takers? Yes. You have a problem? Okay, let's solve the problem.
This is the section. Select on your, this is the stem of the click on the stem of the section. is not happening. Yes, first of all, select the section. Select the points. Select the end. Yeah, make sure your section is big enough, right? That it encompasses the end. This is the extent of that section, right? So here, this is the extent of the section. You can take it more, take it more, so any other takers? How many square foot? Okay, we have 80 square foot from online. We have 78, pretty close, but we'll take these two and we'll try to identify how much we actually have. So first, let's go to the section. This is that section that we want to find for this particular wall. So first of all, let's identify the entire wall, right? Entire wall, what is the square footage? So we'll start measuring it from this point to this point, 11 feet 3 inches, and then the height from this point to this point, 9 feet 10 inches, correct? Now we'll go to the calculator. So what was it? 11 feet 3 inches by 9 feet 10 inches, that is somewhere around like 7. So we are getting around like 109. That is with the glass considered as well. But glass will have a different heat transfer value, right? Which we have already calculated over here for the West glass. So this 21 needs to be subtracted from that 109. Does that make sense? It's the opaque area only that we are trying to consider. So we'll go back to the chart. 109 minus 21, somewhere around like 88, 89 is what we are looking at. Did that make sense? Okay. One more time?
Yeah.
Okay, all right. Let's go over it one more time. So this is the section. First of all, we'll go to the floor plan. Level wall floor plan. We are talking about this west facade wall over here, right? We'll go to the section, either right click, go to view, or simply double click on that section, and then that will get you to the section view. That will get to your section view. Okay. First, we are trying to identify the entire area of the wall with the glass as well. Okay. So the entire area of the wall from here to here, right? That is somewhere around like 11 feet 3 inches, and then the ceiling height 9 feet 10 inches. That we are looking at for this entire area. Let me draw a filled region over here. So we are looking at this entire area over here for the filled region. So this entire area we are considering, right? But the opaque part of this particular wall is only this outside area, not the glazing. Glazing we have already considered it, right? So this area minus this area is what we require for the wall over there that we are going to enter over here. Does that make sense?
Yeah.
All right, definitely. One more time. So the external wall we are talking about, okay? The area of the external wall. Okay, this we'll talk about. This is different. This is just annotation. We'll talk about this as well. I just wanted to make sure you understand the concept properly. Okay. So this is the area for the exterior wall. Okay. Understood?
That, sorry. So this is the room that we are talking about, right? So we go to the section, level 1. This is the wall that we are talking about, correct? We go to that section. Now we are talking about this particular area in the section view. Is that clear? Are you sure? Okay. Now that area minus this area is what is giving us the area of the wall. Of the, yes, please.
How did you select the area of that room?
Of the room?
Yes.
Room.
Where you are squeezing.
Oh, this is not a room. This is just an annotation element. This is a filled region, something similar to a hatch in AutoCAD. Okay. We'll go over this as well in some time. The reason I just used it, this is later on in the topic. The reason I use this is only to make you understand what is the area of the wall and how much we are subtracting from the wall to get the actual area that we require. Okay. But the fundamental what we require is the length over here, from here to here and then here to here. That was basically what I was trying to do with that area being that big. Okay, we'll come to this again. Don't get confused over here. And then we are subtracting this much area, right? So we were talking about 109. That was the particular 11 feet 3 inches into 9 feet 10 inches, right? That gave us 109. And that 109 minus the glazing area that we had over here, 21 square foot, is what we got for west wall. Is it more confusing? The main thing is I wanted you guys to understand that this is the opaque area. The heat transfer that will happen from this outside area will be less as compared to what is happening in the glazing area, right? Because it is opaque. This one is transparent. It has much more capacity to have convective as well as radiative heat transfer as compared to what we have over here. Does that make sense? Sure? No? Did someone say no? Any question? All right. Okay. So Tomiwa, 80 square foot. Is there any other explanation you had? If you can put it in the chat box and we can discuss over that as well. But anyway, coming back to the topic over here, that we will be using 88 square footage as the wall area. Yes. Of the opaque wall. 109. Yep. Yeah, that's length and width. Okay. So let's go into some more basics. So we have 12 inches in a foot. Okay. So when you divide 1 inch by 12, that will give you the decimal for the 1 inch in foot. Okay. So let me open up the good website that I usually use. So this is one of the websites that I use very regularly to convert the inches into decimal foot. Okay, as you see, 12 inches equals to 1 foot. Right now, when we were talking about 11 feet 3 inches, right, something like that. So 11 feet 3 inches comes to 11.25 feet. Right. You guys can use this website as well. It's very user friendly. If it is 7 inches, it will come somewhere around like 0.583. So that is where I was adding that decimal values for conversion. Is that making sense? Sure? Understood? No? No? So how much was it? We are talking about, let's go back over. We are talking about 11 feet, almost 3 inches at this point, right? 11 feet, 3 inches. So that becomes 11.25 foot. We are converting those inches into foot. Now, we are talking about the height, right? So from this point to this point, it is 9 feet, let's say 10 inches. Okay. 9 feet, 10 inches. We are converting it to decimal foot. That is 9.83. Understood now? Okay, perfect. All right. Now let's go back to our spreadsheet. If I can have everyone's attention. We will talk about the next point that we are going to discuss over here. That is the U value selection. Okay. Again, once you have, yes, please.
I need 20 sheets as well.
Maybe try to. Yeah, one more point, you would require a valid license of Microsoft for using the spreadsheet. So if not, try to upload it onto Google Drive and try to use the Google Sheets. I'm not sure, I've not used it. It just occurred to my mind. Google Sheets are open for everyone to use. So check if that works. Okay, all right. We have come a long way. Yes, please. Yeah. So the question in the in-house was, when I'm measuring the wall, why did I go all the way out over here, right? Why not I just keep this area this much only, right? Why do I take this also into consideration? So now let's go on to the level 1 and let's try to check. When we were doing the measurement for this wall, we considered this much area, right? In that area, this length was not considered. But heat transfer is bound to happen from that area as well, right? So for that, we mean on this part, I took it from that point to this point, trying to consider all of the heat transfer possible. Now, of course, it's not going to change the fan coil units by a ton or anything, but as close to best results as we can get, we'll try to get through it. Does that make sense? Okay. All right. Okay. So now that we have that into consideration, we'll talk about the U values. Okay. Just to standardize things for this project, we will consider that the project is in Kigali. All right. Of course, your project can be anywhere and you can use that data. But for the sake of this particular exercise, we will go back to the ASHRAE read-only website. So if you can also open up the read-only website. And in here, yesterday we were looking at the ASHRAE 170 standard. Today we will look at the ASHRAE 90.1 standard. This standard is for the energy standard for buildings, except low-rise residential building. What does a low-rise residential building mean? Any building that is less than 3 stories tall. Okay. When it goes above 3 story, the jurisdiction might consider it as a commercial building. and then that will come into ASHRAE 90.1. All right. So now we consider the IP version of 90.1 2022 energy standard for buildings, except low-rise residential building. Let's go ahead and open that one for the IP system. Give it a moment to open up. Again, it is ASHRAE read-only 90.1 2022 energy standards IP. Excuse me. All right, so just to give you a tutorial, similar to what we had yesterday for 90.170 standard, this is the ASHRAE 90.1 standard. It is used by all of the engineers throughout the world. So I would recommend you take effort to read through this document, understand this document, what it entails, how it works, how it not. All right. So just like the interface we discussed yesterday, there is bookmarks for all of the all of the sections. In the end, you will have the appendix. All right. In the appendix, we'll try to identify the different areas where we can have the we can have in the very end, you'll have the annexure A reference standard reproduction from ASHRAE standards 169. What this is giving you, gentlemen, is the zone where our project is going to be located. It is a very long list. It has zones. We are talking about climatic zones. Yesterday we had a discussion, like in the northern part of Rwanda, the climatic conditions differ a lot more than what we have in Kigali. It is a lot cooler. That's what the feedback I got, right? So that based on the weather station, ASHRAE has classified different zones for most of the places on the earth. Okay. Of course, in US, they will have more granulated data. But for country like ours, be it Rwanda, India, Nigeria, there might not be so many stations, but there will be stations enough that we can refer back. Okay. So this is again, if you go to the bookmarks, in the end, you have annexure 1 reference standard reproduction, in which you will get the climatic conditions for different areas. So it will begin with the US climate states, climate zones. We'll keep on scrolling to check till we get to the international areas as well. Just give it some time, it's loading. So from page number 418 onwards, you will have the weather station data for different areas throughout the world. So this is again Canadian. So go to Rwanda. Slovenia. Yeah. Spain. I'm taking too much time to find Rwanda. Okay, is there Rwanda? Rwanda is not there?
Go from Russia to South Sea.
Oh, okay. Why couldn't I just... Okay, yep, looks like Rwanda is not there. What we can do is we can try to find another location. Is there Africa that we can... South Africa. Tell me closer countries near Rwanda. You have Kenya, right?
Yes.
Okay. So looks like we have the data for Nairobi over here, right? In Kenya. I understand that there isn't the direct similarity with what we have in Nairobi, but we can at least understand that the zone that we are trying to look is somewhere close to the 3C zone. Okay, there are different zones for different areas. The 3C zone is what we will try to work with because that is the closest zone that we can identify ourselves with. Okay, any other areas that you would recommend apart from Kenya, which might replicate closer to Rwanda's? About Kampala in Uganda? No? Nope. Any other? What is that? Is it a look?
The capital city of the DRC.
Huh?
The capital city of the DRC.
Okay. Well, we'll go with...
Which is being fired.
Yeah, I understand. Well, we'll go with the 3C climate zone. Okay, so the reason I'm saying 3C climate zone is because ASHRAE 90.1 will give us the U values that are required for us to enter over here. Why do we refer to ASHRAE 90.1? Because we have a standard, right? This standard is based on similar climatic region, similar climatic zones throughout the world that have given best performance for that particular zone. Okay. So in this case, we are looking for the glazing's U value. All right. The thermal transfer coefficient we are talking. So over here, we will check in the R value in the insulation for, let's check for glazing, building envelope, forest glazing, fenestration. Okay. So in the normative appendix A, rated R value for insulation and assembly U factors are given. Okay. You have different, like you have above grade walls, you have below grade walls. When we come to walls, we will go to above grade walls to find out how much is the U value, how much is the R value, so on and so forth. Okay. In this case, we are talking about fenestration. Fenestration, be it in the case of skylights, many a times on the roof, there will be a hole and then that will direct skylight into the habitable areas. As well as there is vertical fenestration. Okay. Vertical fenestration is what we are looking over here. The windows that are on the walls, vertical walls. Okay. So in that case, we will click on the 8.2 unlabeled vertical fenestration to get an idea what is expected of us from the vertical fenestration. Now, over here, we are talking about the glazing and its U value for the calculation purposes. Okay. This same U value, we will put it in the calculation over here. Make sense till now? Now, we are talking about the glazing, but this is for skylight. Okay, we don't want it for skylight, we want it for vertical fenestration. So we'll scroll down till we see vertical fenestration. Unlabeled skylights. Unlabeled vertical fenestration. Okay. So the U factor for these vertical fenestrations is given over here. If it is a clear glass which does not have any tint to it, we will take these values. If it is a tinted glass, we will take these values. Okay. Now we will have different type of framing associated with the window. Okay. If we go into the Revit model and we go to the elevation, you will see that there is a framing that surrounds the glazing, right? We need to understand with the architectural set that what is the framing made up of. So in this case, it is a rectangular mullion. Not sure what the architect has specified as the... Okay, one more thing. Again, tab select has selected this particular curtain wall mullion. If I click on edit type, it will bring up this type properties for this particular element that I have selected. Okay. In addition to the properties that you see over here. All right. In this case, the material for the framing is aluminum. Just basically classifies under the category of metal and other frame types. Does that make sense? These are aluminum. So this will also come under this metal and other types. Okay. Next, talking about double glazing and triple glazing. Right. So the triple glazing will give us better heat reduction, heat resistance value as compared to the double glazing. Okay. But we'll go with the double glazing in this case because right now, even if they are showing it as single pane, what they will install will be the double pane. What is a double pane? This basically two glasses installed side by side in parallel with a small air gap in between. So there will be an assembly of that particular window. Okay. And that assembly will give us the value of U to be 0.9. Okay. If you did not know what the exact type of frame is, you can use all other frame types. Okay. If you know if the window frame is made up of wood or fiberglass material, you can use this tape. Make sense? Sure. Okay. So 0.9 is what we will be using for the glazing over here. For all of the windows, we'll use 0.9. Oh, sorry. Yes, yes. Sorry.
Right. Yes, yes. Well, as per the building code, the single metal frame for this particular client is not as per the slab. That is what is exact. So we as HVAC engineers, when we are talking with our client, we should put them to have their double frame with some gas in it, be it air or be it argon. We need to push for that. That in itself is going to help us remove the heat transfer and run the HVAC systems as well. Because this has happened. This has happened on one of my projects. It's located in Rabik in Saudi Arabia, which is about like an hour drive from Jeddah. The building is certified for LEED. We had a triple pane window with argon glass filled into it. The client visibly was saying, even if the AC systems are not working in the month of August, they are feeling not that hot without AC in Jeddah, which is supposed to be one of the most critical areas for cooling. So it does pay dividends. It's just about us portraying the client properly. You can add a U value for a single pane over here. That is fine. But then give them a comparison as well. With a single pane, all single pane, your HVAC, let's say, is 100 ton. With the double pane, it might come down to 75, just an assumption. So these comparisons, when you start giving to the client, that's what starts making the difference. Now, of course, the first cost will be more. I agree with that. First cost will be more. You can try to compare that with the energy cost, because this first cost is just one time. The energy bill will be coming every month to them. So do they pay that time or do they pay right now? Right? Sorry? Absolutely, absolutely. And that spreadsheet, once you fill out, give them comparison between a single pane and a double pane, how it is working out. I'm pretty sure they'll be aware, cognizant of the fact that yes, we need to go this way. All right. Okay. All right. So 0.9 is the U value that we have considered, right? Similarly, looks like we have about 20 minutes. We'll try to finish this room as best as we can today itself, so that tomorrow we can jump into other rooms as a template. Next thing is regarding the U values for the walls. Okay. Going back to ASHRAE 90.1. Over here, you have two types of walls. You have above grade walls and you have a below grade wall. Is everyone following? Yes, right? Okay. So above grade wall, this is an above grade wall. All right. Below grade, let's say you have a elevation, you have a terrain, and behind this wall is earth. That becomes a below grade wall. There is heat transfer through the earth into the room as well, from the floor into the room as well. You need to understand that. So in this case, in our project, looks like everything is above grade. So that's why in ASHRAE 90.1, we'll focus on the above grade walls. So now it starts with different types of wall. Is it a mass wall like a brick wall? Is it a metal stud framing wall? Is it a steel framed wall? Is it a wood framed wall? In most of the cases that we will work on, mostly it will be the mass wall with bricks that will be built, right? Be it fly ash brick, be it like clay bricks, so on and so forth, right? So over here, once we go to the mass wall, we'll consider this as a mass wall. You will again have a table associated with the mass wall. And it is giving you the assembly U value for above grade concrete and masonry walls. Okay. So now you have different columns over here, which will give you rated R value for insulating alone. So if you have an insulation
So the plaster that you have outside the wall is a form of insulation. If you want to go above that, there is another insulation material that you can just have for insulating the material. The more insulated your walls are, the less heat transfer it will have from the outside to inside. Indirectly saying the AC units are not going to work that much, saving the cost on the long run, right? If now we are talking about these insulated values, right, over here. So now if you have no insulation, we need to use these as the R values. Okay, R values reciprocal 1 upon R value that you have over here. If it is R11, 1 upon 11 will give you the U value. It is reciprocal. 1 upon U value will give you the R value. 1 upon the R value will give you the U value. Make sense? All right. So now let's talk about the framing. We don't have any framing, but we'll check what the thickness of the wall is. Okay. In our case, let's go to our model. Similarly, that we were checking the area of the wall, we'll check how much is the thickness of the wall. In this case, it is somewhere around 9 inches. All right. 9 inches. Let's consider that whole and soil is 9 inches. Looks like we have 8 inches tops, and along with that there might be some R value that might be associated with it. So for our sake, we'll take it at a 8-inch nominal weight wall at 8 inches over here. So the U value that we are talking about, 0.083, is what we will consider for the walls. Okay. Again, this is a coordinated effort between the architect and yourself. This is something that the architects will have on their details, architectural details. We need to read the architectural plan and we need to assign it accordingly. Okay. If you notice that the U values are not meeting these standards, you need to let the architect know that we are in these particular climate zones, and that is where we need to have the U value assigned properly. Make sense? So there is a lot of collaboration going on. So with that, we'll have the 0.083 as the U value plugged into our U value over here. 0.083. All right. Now let's talk about the next point is regarding the roof over here. So over here that we are talking about, on this room, there is another room, right? There is another floor on this floor, right? In that case, we do not have any roof associated with this floor. It will be associated with the floor above. The second floor will have a roof. The ground floor will not have a roof. Rather, we'll need to take into account the floor that can transfer the heat from the earth or back to the earth from the room. All right. So over here, the area of the floor that will be exposed will be basically from this point to this point, and then this point to this point, right? That is the floor area that we are considering. Now, once we go over here, you will have the floor area over here. That is where we will consider the floor area. Let's remove all of these because we have already entered the class. We are not entering the partition. Floor, we will enter it. It is 10 foot 6 inches by almost 12 foot. So 12 into 10.5. Oops. So we are looking at 126 square foot as the area of that room. So over here, 126 foot, right? Now, talking about the infiltration, we'll use the infiltration on the other side over here for the cracks. Let's go ahead and check regarding the people load. So first of all, we'll need to understand how many people are required to be in this zone. Okay. So over here, you will enter the number of people that are expected in that room. Okay. So if it is a patient room, right? A private patient room, a luxury patient room, right? Deluxe, they call it, deluxe patient recovery room. There will be just one patient in there most of the time. and then there might be guests coming in back and forth. So there will be 2 people in the given room. All right. So we'll consider this as a luxury patient room, and then we'll have just 2 people in there for. Okay. So that is where we'll enter only 2 over here. Okay. And 5 CFM per person, we'll talk about this as well in some time, because this relates to another standard of ASHRAE 62.1. We will talk about this in general because this is what we will talk about for the minimum air changes per hour that we were talking about yesterday. Coming back over here, lighting. This lighting also comes from the ASHRAE 90.1 standard, where we have, as per the area of the project, you have certain watts per square foot that ASHRAE 90.1 will recommend to you. Okay. For now, we will understand it. It's somewhere around like 1.25 for a typical hospital area. But if you want to do deep research, you can simply go to ASHRAE 90.1. Over here, you will have lighting, and in there you will have the you'll have a table that will get you. That will give you the wattage per square foot that is allowed. Okay, here is the wattage per square foot that is allowed in different sections. You can do a deep research into it. Like for hospitals, there might be a different given 0.92 watts per square foot that is required. So that is what will be basically entered over here, watts per square foot. To be on a safer side, we have 1.25 watts per square foot that will be emitted by the lights. On the other hand, the equipment. Now, equipment is something like a heart rate monitoring station, right? If there might be some motors associated with the stretcher or the bed of the patient, that is also going to emit heat. So based on the equipment cut sheet that we get from the architects, we'll make sure that we enter the wattages over here. But this for a typical patient room is anywhere between 500 to 1000 watts, 1 kW, right? So we'll enter 1000 watts over here. Now, as you see, we have entered all of the information. The information on the right side, we will check now, all right? Before going too far, we will enter the name as room number 1 that we are mentioning. The area. Now, this is the same area that we have considered for the floor. So the floor area, what we had was 126 square foot, right? And the ceiling height was somewhere around like 9 feet 10 inches. So 9.83 is what will have the ceiling height. So this will essentially become our volume of the room, right? Next, we'll go ahead and start identifying these numbers in ASHRAE MEP. So yesterday we spoke about ASHRAE MEP. Over here, you need to search for ASHRAE MEP. We'll open that website. Now I know we have taken the climatic zone in 90.1 for Kenya. But over here, since we have that data available for Kigali, we'll enter this information from Kigali. So this is the Kigali International Airport's data. Over here, now we'll take a look at the cooling dry bulb and mean continental wet bulb temperatures over here. Okay. So over here, 30.2 degrees centigrade is what we want to enter, but we'll change it to IP so that it matches to the calculations that we are doing. So 30.2 is somewhere around like 86.3 degrees centigrade. 86.3. The wet bulb will have it at 65.5. And we are talking about the relative humidity to be somewhere around like 60% at the given worst case scenario. 60 to 70%. So over here, now we come to the location for ASHRAE 170. So yesterday we went to ASHRAE 170 standard to check what the option is. We'll consider this as a patient room. Let's open the same PPT that we had yesterday. Okay, so yesterday we went through this PPT where we had the patient room somewhere around like 21 to 24 degrees centigrade. That is a dry bulb that we need to design it at. So that is what we will enter it in this column in the dry bulb. Okay, so we'll take it around like 23 since we are given the range. So 23 centigrade to Fahrenheit. We are talking somewhere like 73.4. Right? This is what the delta T that we are talking about will be calculated for. Okay, is that making sense? The delta T? Yes. Okay. So 12.9 is what the delta T will be over here as well, because we are trying to maintain the temperatures as compared to the outside. All right. And this is basically giving us the information for if I remember it right. This is giving us the information for the wattage that we require. Now we don't have a roof over here, so let's remove the roof from here. Okay, so gentlemen, this is what we are coming up with for the total area that we have. What happened over here? So this is one by one the BTU per hour that we are talking about. This is the BTU hour for the windows. This is the BTU per hour for the north wall. This is the BTU hour for the west wall. We are talking about the BTU hour for the floor over here. We are talking about the BTU per hour for miscellaneous loads like, not miscellaneous, latent loads like people, internal loads like people, lighting, equipment, power. And at the end of the day, for this particular room that we are talking about, we are looking at a air conditioning unit that is required to be around 1.94 kilowatt. 1.94 kilowatt. Does that make sense? Okay, one more point. I forgot to add something over here, which was the outdoor air CFM. Okay, so instead of the CFM per person and CFM per foot, what we will do is we will refer to ASHRAE 170 for the minimum air changes per hour that we mentioned yesterday. So let's consider this as a patient room where we need to have a minimum outdoor air changes per hour as 2, right? 2. Now we are talking about the conversion from so this is just a calculator that you can use for calculating the CFM or air changes per hour. So wait just a moment to load. So I'm just doing a regular research, search for air changes per hour calculator. It's pretty straightforward. For some reason, this this one is not opening. Okay. So this is a simple this thing for calculating the room area. So as we saw, our room area is somewhere around, how much was it? 126 square foot. What we'll do is we'll just add 1 into 126, because at the end of the day, they are trying to calculate the area. The ceiling is somewhere around like 9 feet 10 inches, 9.8 feet. And the air changes per hour that we require is somewhere around like 2. So this is not a good, come on. I wanted to do it backwards, but let's have it as, how much? 9.7. Okay, somewhere around 50 CFM is what we are looking for having minimum air changes of 2. Okay, 50 CFM is the outdoor air we need to bring in for that particular room. Does that make sense? So that is tying up into our exercise yesterday, that we need to have minimum outdoor air changes per hour as 2. Right? That air changes per hour as 2 will have okay. Square foot is 126, correct? 126 and 9.83. And then the air changes per hour that we require is 2. So exactly talking about the cubic feet per minute, we are talking about like 41.29 CFM that we require minimum outdoor air to come into the room to satisfy the ASHRAE 170 standard. Does that make sense? Okay. So yesterday we had this discussion, right? This table we discussed yesterday. This room that we are considering is a patient room, right? As per ASHRAE 170, we need to have minimum 2 air changes per hour for this particular room that we are calculating, right? Outdoor air, we are not talking about total. Outdoor air needs to be 2 CFM, 2 air changes per hour. Now, the air changes per hour, let me check if she has the formula here. Okay, so this is the formula for the air changes per hour. Okay, you will have the air changes per hour equals to the CFM into 60 divided by the area and height of the room, basically the volume of the room. Right?
How can you get CFM?
How can I get CFM? Well, we do have air changes per hour too, right? From ASHRAE 170. Yesterday we saw this, right? As standard. Make sense? So the 2 air changes per hour is being pulled in from ASHRAE 170, which we are plugging in into this formula, and then we are getting the CFM. Now, since we have established Revit model, we know the area of the room, we know the height of the room, basically trying to plug it into this particular formula over here, or calculator over here, trying to get a CFM of 41.29. Does that make sense? Sure? Sorry, I'm not able to see you guys properly, but are you guys sure you understood this topic? Because this is what we'll be applying again and again. I want you guys to get comfortable with this topic as much as possible. Air changes per hour, finding it from 170, and that is why we were doing that elaborate exercise yesterday, because it is all coming to one by one factors. How do we calculate it? It's just not Revit we are trying to do over here. We are trying to understand why we are trying to do Revit in the first place.
The idea is this. If we consider the size of building or facility, needs to have taken us like drawing and starting. Has taken like 1 hour. See your one is prayer every because I don't feel like we can give you instruments.
Yes. See this right there? See this right there?
That was a good one for coming to a conclusion. But yes, man, I wish I could give you a secret. And again, this might work in projects like office, to some extent, schools, colleges, that we can have a rule of thumb. 1 CFM per square foot, apply it. 400 square foot per ton, apply it. But when we talk about projects like these, hospitals, inherently, it is our responsibility of the engineers to put that extra effort. I honestly wish, man, I couldn't give you some secret sauce. And that is why you guys might be thinking yesterday, why did I yapper so much about the theory? This is the one reason why we are going through the theory. And to some extent, I had also asked my mentor the same question in some other form. Can you give me some tips and tricks to avoid so much time for that one? But again, once you get started with this is kind of a practice for you, right? Not sure if you guys have worked with E20 before. If you guys have worked with it, it's good. If not, Carrier HAP is basically a much advanced version for energy modeling, trace, all of these. But until and unless you understand the basics of it, I know we are all experienced over here. We know the basics of this. But projects like this, a hospital project, we need to do our due diligence to make sure we are doing things properly. Yes, sir.
It is good to know the theory behind those calculations.
Yeah.
And wondering if there is software which can help actually data in, so that you can maybe say this is the room for this.
Yes. Yes.
And you select the software for
Yes.
Analyze the
Correct. Yes. So to repeat the question to the online team members, we had a question in-house saying like, instead of going through all of this trouble of the E20 spreadsheet, do we have like a software which will help us basically apply templates, right? Like patient room 2 air changes per hour. Then we have operating rooms, let's say 10 changes per hour, so on and so forth. Yes, there are software out there. Software such as Carrier HAP, Train Trace. To some extent, ISVE has emerged as a very sophisticated software. Yes, they do have it. But the data entry needs to be done in the first place. The wall, the window, the height, area.
That you have to keep them.
Yes.
Like material of the wall.
Yes.
The window, the size.
Yes.
What you keep.
Exactly.
The previous one is reporting all those tables.
This thing, right?
Yes.
Yes.
That is the work is.
Yes.
And the work, the top of the software you put in
Totally understand. Totally understand. Yes, there is available. Once you click on your project location to be Kigali, it will do the work for you to find this database from ASHRAE tables and then use that for calculation. Yes, there is. There is, sir. But those softwares are expensive software. Huh? Sorry? No. For me to explain it over here, it's something different. And since we are concentrating on Autodesk Revit for this class, it is not Carrier app. Maybe we can have. I can surely come back and teach you about Carrier app, Train Trace, ISV, because a big part of my career I've been doing that as well.
We may not get something or those calculations made manually, but the time.
Absolutely. Yes. Agree. Absolutely. And that is what the tools are used for. I totally agree with. Yes. And again, this is something that if a firm does not want to invest in these software, they go for E20 spreadsheets, of course. That relates to maybe lower junior engineering staff feeding in the information and then senior staff QCing the work and properly analyzing what needs to be changed and what not. So usually this data entry, from my experience, I usually have my junior engineers do the data entry and get it resolved. Yes.
Another question that when you are doing for suffering from that, you consider the equipment.
Yes.
Maybe more than look at
You want data centers? Okay, yeah, we can do data centers. But again, yesterday, I think so you only mentioned difference between sensible heat and latent heat, right? Sensible heat is emitted by people, perspiration. If there are a lot of trees, that also perspire, right? So that adds to it. Now talking about equipment, the charger for the laptop, the projector, these are all sensible heat. That will go into the equipment load over here, right? So basically what is going on in a data center we are talking about is, we have the racks in a data center. We have the plugs associated with those. The racks will have a certain U value, that how tall it goes. It goes like 2U, 4U, 6U, 8U, so on and so forth. And how much power it consumes and how much output it gives in the sense of IT, information technology. What difference there is, that will be the heat dissipated. That is all sensible heat. All right. And that sensible heat is basically what we need to take into consideration over here. So most of the heat load in a given data center will be sensible heat. Does that make sense?
Yes, like the reason why I asked such a question, I would like also to advise which appropriate systems dedicated for
data centers. Sure, we can have a conversation. I will check because we still have plumbing and electrical to cover in this topic. We have just gotten started, or maybe 50% with HVAC. I still need to teach you regarding Revit HVAC. Right now, it was trying to come to a conclusion for how big of an equipment we require for HVAC. Now it will be the ducts that we'll be drawing. So we'll not do each and every room. We'll do some typical rooms, but I'll make sure that you identify how to properly place stuff in Revit, because that is our goal right now. Okay. For data center, maybe we can have a conversation. but not in-depth conversation, because that will require again another 4-day session by itself only, and just for HVAC. Okay. Any other questions? Let's go back to what we are talking about here. So with that particular air changes per hour, we were talking about 2 air changes per hour over here for ventilator. That is coming up to the 41.29, the same CFM that we measured over there, right? And then with that, we are coming to a kilowatt of still 1.94, since the outdoor air is not that much, it's hardly 50 CFM. So we are keeping our cooling equipment to 1.94 kilowatt over here, which translates to somewhere around like 6.6 MBH, which is somewhere around like half ton of cooling that we would be requiring for this particular purpose. What is going on? Okay. All right. So this was one room. I was hoping to get many other rooms, but I know Revit, we have just gotten started with Revit, quite few of us. I wanted to make sure that that aspect is also clear, because if you don't understand the basics of Revit, it becomes harder later on to pick up, right? Any questions? I'll try to limit it to this because we are almost 15 minutes over. So right now with this, have you guys understood how we have come up with this number for 6.69 kilowatt? Yes, no? I see many blank faces. Are you guys sure? Any questions? Does that make sense?
It makes sense.
Yes, you have something to add?
No more questions. We'll make our self-prediction.
That's what I was coming to. So even though we have done just one room, I've given you the basics on how to solve the other rooms, right? The rooms will be either oriented differently, they will have a different direction wall. Instead of floor, they might have a ceiling or roof. Instead of a 20-foot window, square foot window, there might be 40 square foot window. Instead of a clear glass, there might be tinted glass, so on and so forth, which will basically affect your heat load calculations in the end. All right. Any other questions? Yes, sir. Sure. Uh-huh.
Let's say 10 buckets, but you can have like this in space, you put your input right here before everything. And then, yeah, you have it. That's what you say.
Yeah, good point. Again, I've done it in Revit, and I'm pretty sure, Maurice, you must have compared it with the E20 and Carrier app. There are differences. Revit right now, it's a collaboration software more than energy analysis software. That's what I would say. And in an ideal world, everyone will model their stuff correctly, right? Like the architect will have the proper U values and R values and the walls properly modeled in Revit. They will have their glazing properly modeled in an ideal world. But we unfortunately don't live in an ideal world. So we need to do our due diligence in the longer run to get it properly calculated. So exercise a bit of caution. It's fine if you do the Revit energy analysis, but make sure you have a very stringent QC done on that energy analysis that you do through Revit. Right? I would rather bet my money on the spreadsheet or the carrier. Software, because those software are meant to do that. It's not meant to do collaboration. They are meant to do the heat load calculations rather than any other suggestions, any other notes, points. So tomorrow what we'll do is done. I want to make sure I have the operating theaters as well done. That is one of the biggest one that you'll come across. And after that, then we'll plan on getting into the plumbing work for hospitals. Okay? We will have a discussion maybe over the tea break for data centers as well. I need to make sure that you get what you're asking from me as well. But yeah, that is something that we can have a sideline discussion, and everyone is welcome to join in on that. All right, cool. All right. Anything from online before we conclude?
Nothing.
They already left.
So have you answered this question that you have you answered this?
Yes. So yes.
So nothing new.
All right. Okay. So engineers.
Many of you are tired more than being tired, guys. So as they say in English they say a bite delicious doesn't stay in the mouth forever. Then in Kinyarwanda we say akaryoshe ntigahora. A bite, something which is delicious doesn't stay forever in the yeah, right. So to those who attended today's session, it's time for Nziza Global to thank you first. Then it's our opportunity to remind you to always respect time. So on the behalf of Nziza Global, let us thank you for your participation and your active. So I hope everyone gonna have a fruitful night. So have a good night, have a good month. Thank you.